Recording in progress.
Two mics will take
Bapak Ibu semua, Bapak Ibu sudah bisa kelihatan share screen? Oke. Halo, Bapak Ibu sudah bisa kelihatan share screen-nya?
Sudah, Pak.
Sudah Pak, jelas Pak?
Sudah jelas, Pak.
Sudah Pak ya, oke. Makasih Pak ya. Nanti kalau ada masalah tolong dihitungkan Pak ya, diinformasikan. Makasih Bapak Ibu.
Trial. 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 Trial.
Hello. Hello. Wait, am I audible?
Okay, clear.
Okay, thank you. Okay, just one more.
Oke, suara sudah masuk.
Okay.
Your voice in.
Okay. So yeah, it's just switch off the speaker maybe. Maybe one of the mic you can switch it off. Okay, good morning everyone. Let me start off then. So not to stretch it too much. My name is Vishwa, Senior Structural Engineer in Bentley. Since 2007, I am in Bentley, and before that, I was in different consultancy firm. So mostly, it's been a long journey in Bentley, around 17 years, and mostly into STAD and RAM lines of products. Previously, I was in a technical support on STAD and RAM. Then I moved on to different user engagements, delivering the training, understanding the user's pain point, working on different projects, working together with our development team. So anyway, so by the way, can we hide this? Just like this. Like this. So before I start, I just want to have a quick round of your introduction. So where are you coming from? What is your expectation on what is your understanding of STAD? What is the level of your familiarities? Be very slow, no matter. I understand that might be having some communication issues. So just give your introduction, quick introduction, like what is the level of your familiarity or experience in STAD or some other Bentley products? By the way, is my voice, my pronunciation okay with you to understand? Or shall I go slow? Okay. Okay. So you can start from this side. Yes. Not your total experience in the sense, just give your, your industry and your experience instead. Don't be shy. Be very open.
Saya pakai 1 dari 10 bulan.
10 months. Okay, great, great. You are in. Okay, no problem. No issue. If you have any issue in communication, please interrupt me. We have our interpreter. No issue. Common thing is we have to communicate, right? Now, you are in structure or concrete? Means steel or concrete? Steel. Okay. Fine. Okay, great.
For myself, I've been using STAD from 16 or 17 years.
Okay, so you're a very experienced user. Okay.
Mostly in oil and gas.
Okay.
Industry.
So mostly in oil and gas. So you're using which code? ASC code or API code?
European code.
Okay. API code?
API no. API using SAP.
Okay, okay. You're also using SACS, right?
There are 2-3 projects using API.
So which version of STAD you are using now?
The latest one.
So the 2024?
IPPT. So we are using the latest.
2024? 2024 STAD.
Yes, let's go. Oh, 2022.
2024 we have recently launched, but very similar. I'll just give you some introduction. Yes, madam.
Use STAD Pro almost 3 years in LNG.
Okay.
Yes.
You're also from oil and gas mainly. Okay. So in the steel or concrete? Mainly steel or
Sure.
steel. So you're also in steel mostly, right? Both steel, concrete.
So because pipeline also we have with us.
Okay.
Building.
Okay. For you?
I've been using Subco for almost 2 years, mostly in oil and gas and I use for the design of steel and concrete.
Okay. Yes, sir.
Yeah, hello, my name is from AI, and maybe not using Subco.
Okay. Okay.
But in this project I use Subco, sub 2000 and DevOps.
Okay.
But recently years I use Subco, but I'm not in just in the project for the design.
Okay.
So this is the first time.
Okay. So you are mostly in the concrete structure, right? Building structure, right? Both.
Previous project I have managed building, so I use DevOps.
I see.
But in these 3 years I use Subco. my college.
Mhm.
So my level is still beginning.
Okay, great. How about you?
I am from Rio from the engineer. This is my
Okay, okay, good, good. And you?
I'm Muhammad Mulo from Perjalanan Muda.
Mhm.
I'm not into using stuff here to learn stuff.
Okay, okay. Steel, concrete, both you are working.
Hello, my name is Chandra. I'm a assembly partner from IKBP. I'm using stuff for around 2 years in concrete and steel.
For infrastructure, oil and gas, buildings, office teams.
Yes, yes,
Okay,
and my expectation to come here is to know more about Bim-Structural
okay,
in Bentley and how to connect it with other Bim software.
okay, okay. Yours?
Is the
Okay,
and new.
okay, okay. So which type of structure you are handling?
Okay.
Okay, okay. So here you can see we have a very mixed audience. Some of you are very experienced, some of you are from steel, from concrete, some of you are, I can say, intermediate or beginner. But all of you have the expectation like what's the new updates, what we can do. So maybe I'll just have some balanced workflow so that it should not be like only the updates and advanced things I'm showing and some of the new users are missing, and it should not also be like only the basic things I'll be showing. So I'll be just touching upon few of the differentiators because it's a very vast subject. It's not only stat, some of the connected products like maybe RAM connection, we have steel autoductor and so on. Okay. So anyway, so with this note, I'll just give a quick intro. Before I go ahead, just recently, I just want to show you some of the success story we have, and then we'll just go into some of the differentiator, some of the updates, and maybe we can discuss on some live or maybe some live model. So this is in India. It's a kind of bungee jumping structure. It's a huge structure. And you can see that it's a very tall structure. It's a kind of steel frame structure. Am I obstructing the view? Maybe because I can pull this back. So the challenge here is of many folds. First of all, it's not a simple structure as it seems, but it falls in the fault line of our Himalayas belt. Himalayas, the tallest mountain range. And this is highly seismic prone zone. And not only that, it's subjected to several harsh climatic conditions like extreme wind, rainfall, landslide, temperature variations, and so on. So we have so many challenges. So actually we didn't do, but our consultant did that, and we always try to advocate them how to, guide them how to deal with this. Now you can see here, it's a tall structure having a boom length of around 27 meter, and the drop height is around more than 100 meter. And it was supposed to withstand the extreme climatic condition. So our skeleton consultants undertook this project. They have used our product, STAD. Now, when I say STAD, it's not only about STAD, it's with the Structural Enterprise Work Suite. What is that? I'll come to that a bit later. So what it did? It's a kind of mostly the steel. You can see some of the bases here. These are small little foundations or small stubby columns. But as I mentioned, it's a super tall structure and it's subjected to extreme climatic condition, including the wind, extreme wind load. So it was modeled with normal steel structure and with the pre-tension cable. And in this boom, this hoisting or mounting passenger cabin was supposed to move around. So a lot of things were considered. First of all, advanced cable analysis was to be performed. In addition to that, moving load, which is moving all across this portion, was also been modeled. Okay, so this is just a project overview. Second is one of, then I'll just go to the normal presentation and then with the model. This is another differentiator we have. And this is where you can also have some idea of this beam workflow a little bit. So this is the bridge in Rishikesh. This is also in somewhere at the northern part of Himalayas. And WSP, as an international client, you know, might be aware of them. They were constructing a bridge, not the normal bridge. It's a railway bridge, along with the complete alignment of the railway track in this rugged mountain. So you can see there are a lot of challenges we have, not only like structural parts, but also the alignment part, like how the alignment would be. So we instead, not only we are dealing with the structural part, we also have other products like open rail, open road, open bridge, and so on. So with the different combination of products, we could deliver them. And we have different sects where we need to model those tunnels. So they have used that mostly for the structural part. You can see, because it's a railway track, right? So it's not a road like we can go winding and all across the hill. It has to maintain some linear alignments. So there should be a lot of cut and fill wherever it is needed. We have to go through bridges and go inside the hill through the tunnel. So we instead have something like called scenario optioneering, by which there could be different types of arrangement, like, right, for a bridge or any kind of, even for building. Now what you do, you open different models separately, right, and try to analyze them separately and just compare them, which one would be the most optimum one, right? So you might be wondering, like, instead there is something called run cloud analysis. Have you ever come across? Did you see while you open stat, normal analysis, and there is something called cloud analysis? Okay. Now, cloud analysis is a kind of dedicated analysis. We need to have a separate, service for this. The benefit here is you can run the multiple type of geometric arrangement, and you needn't have to, in your machine, you needn't have to perform the parallel computing. So in the cloud, you can ask for multi-parallel computation, and you can get all the different design parameters like utilization ratio, steel takeoff, and so on, so that eventually you can compare them and you can just see like which one would be the best suited, structure for you. But this is kind of separate service you need to take. So they have used this one for different, we call it the optioneering, because there could be different kinds of arrangements, right? So yes, in cloud, it would be much more smarter and faster way to just quickly select the most optimum one. So there are a lot of different options, right, in the truss bridge or any kind of structure. So yes, those who are new to STAT, I'll give you some introduction, and then you can have some understanding. But this is just an icebreaker before I start off going in directly into the STAT. So yes, you can see that there are a lot of things we need to deal with. We have this deck, steel, those arrangement truss system. Then we also come across different connection where we have to do the connection design, steel connection design. So yes, the entire workflow, if I say, it's starting from the data collection to span configuration. Structural configuration means different types of structure, up to the drawing generations. So as a structural engineers, our job is not to just stop designing the member. That's all. We have a lot of things to do. We need to collect the data. We need to check that the data is good or not. Then we need to import the data, as you mentioned somewhat, like Beam. Beam is one of the part of this. After you deliver this, there are a lot of other things we have to do up to the detailing, right? So the workflow is very important here. So the project outcome, like STAT played an important role there because obviously the design and everything has to be done in STAT, analysis design. But yes, the entire workflow has to be done with a very smarter approach so that it can ultimately what? As an engineer, what we need to do? We need to certain that the design is perfect, demand and capacity ratio is okay. But at the same point of time, we need to ascertain that our project is cost effective, right? It's not like we are selecting some heavy sections and we are done with this. It has to be saving a lot of resources. So yes, these are the project outcome. You can, if you go to even the Google map, you can see this is a very rugged terrain, beautiful site though. But yes, building the train track is a very challenging task. So yes, we have a different set of train tracks built over there. And it helped a lot of employment to the local community, as you can see. So yes, so how we achieve this optimized design by STAD, saving significant man hours, critical assessment in the construction stage by incremental launching. So this is the project outcome that we have. And this is one of the biggest success story. If you go to our Bentley website, you can also see there we have a lot of detailed discussion on this because this is one of the winner of our projects. So anyway, let's go into our structural part. So right now, we call it the structural work suite. So how many of you heard of this structural work suite, by the way, or we're using the structural work suite? Any one of you? Structural work suite you are using, sir? Or at any point of time you come across? What is it? Is it a product? Is it a solution? Is it a license? What is it? Anyone? Okay. So every one of you have heard of STAT Pro, right? At any point of time, even if you have not used, you have heard of STAT, right? STAT is a kind of, we all know that it's a structural analysis and design product. But let's see what we can do. If we give you this building, okay, it's made of, it's a Reliance Convention Center in Mumbai, in India. It's a huge structure. It's made of different materials like steel, concrete. Some of the non-structural elements are also there, which we have not modeled here. But the point is, you can see this purple color is a concrete, and the top one is a steel roofing system with the shed. So if I ask you, like, what are the different products you will come across here? Or what are the different products you would need for submitting your project for structural design? Is that enough for you? Yes or no? Okay, why STAD is not enough?
Yes, if you design without the concrete.
Yes, yes.
Also the foundation,
Mhm.
and it's more advantage again if we can extract the problem.
Yes, very correct. So yes, so main purpose of STAD is performing the analysis, because finite element analysis is one of the most complex tasks. Obviously, we assume that you are not going to manually solve this finite element analysis of such complex structure. STAT can deliver you a very good steel design. Okay. I think you are also in the oil and gas industry, so mostly steel structures. So how you are designing in STAT? Steel structure. Yeah. So in steel, we can say that we have a lot of users, even for oil and gas. We have Motmac, we have Ochre Solutions, Petronas, a lot of our users. They've been using STAT for a long time now, Jacobs steel structure, because there are a lot of things you can customize, orientation, section sizes, and all. We have OpenStat. And another advantage is we can not only design steel sections, but also we can optimize it. Okay. Any one of you have heard of this optimization you have used? Steel optimization? Oh, manual. I'll come to that. We have a command called select command in STAT. Okay. That's very important differentiator. Select command is not only meant for designing. For example, you have taken a section You perform the analysis. You have designed it as per the code. After design, what we will see, some design ratio, right? 0.1 is a design ratio. So what do you think? Is it okay for you? Design ratio. 0.1 means what? Demand versus capacity ratio is 0.1. Means the capacity is 10 times more than its required demand. Obviously, you need to reduce the section depending on the codal clauses and everything. Now, yes, you can go for the different manual checks and all. That's obviously you have to do for verifying different step results. But yes, we have something called select command, which is automatically picking the next lighter section. And it is again doing the same set of design cycles until this ratio is less than 1, but very close to 1, something like 0.8 or 0.9. So by this way, we can optimize the steel. I'll show you these are very powerful things, and maybe you can try exploring this. Okay, so STAT is very good in analysis and steel design. But what about the detailing, as you have mentioned? So once we do the steel design, we have something called steel auto drafter, by which we can generate the drafting drawing. Okay. So in the steel auto drafter, you generate the detailing and you can save it in the CAD file for generating your drawing and all. So we are done with the steel member design, detailing. What next? Member design is done. Is it enough for your steel structure? We need to establish like connection design, right? We are good with the member design, but what if the connection fails? That is the reason we need to have some solution for connection design, and we have something called RAM connection here. So yes, steel part is almost done. Next, concrete, right? Now for concrete, I have a question for you. So how you are dealing in STAT? Because this is a very tricky answer or tricky question. Because every session or every webinar or every kind of seminar I go, they have a lot of questions like which approach should they use. So any one of you using STAT for concrete design, by the way? No one? You?
Detailing of the concrete?
No, designing. Detailing will come later on. Designing.
Yes. We are often using
STAT Pro.
for building concrete.
Oh, okay. RCDC, Advanced Concrete Designer.
Yeah.
Then the design which is already inbuilt in STAT, you mean, right? Concrete design, like design column, design beam. Okay. Okay, that's good part. There is a discussion on this. So I'll just, there's a reason I've asked this question. And this is not my question. I have been going so many places that every users are asking like on this tricky question. I'll come to that, why I've asked this question. We have something called RCDC or Advanced Concrete Designer. If you're in the industrial structure, then this will not be that much effective if like pipe rack and all. If you're in the building structure, then it would be very much effective. Why it is so? I'm coming to that. Flat slab, like post-tension slab, normal slab, hybrid slab, we have RAM concept. And finally, the STAT foundation. Now, everything is very much clear, but this one, let me throw some light to this. Sir, do you have any blackboard or any whiteboard? I want to sketch. So I think I will put this. Okay, forget it. Maybe later on I will come to that. Generally, I prefer a side-by-side blackboard. Yeah. Everything can be shown in the slides. Now, what happens within STAT, let me give you some interface just to show the interface. So within STAT, we can design the concrete, okay, as this gentleman has mentioned. So we can select a lot of different concrete codes and everything. So there is a command called design column, design beam. In some codes, there is something called design slab. But Please pay some attention here. Okay. So the point is, we can design here, no issue, but there are some kind of things we could not do. For example, physical member-based design. Second is very detailed detailing, bar bending schedules, bill of quantities, which is mostly done for normal building, industry. Like just designing is not enough. We need to also do the detailing. And not only that, if you have worked for a long time now, might have noticed that if this is a floor and you have modeled with the plate elements and the beams are surrounding this floor, if you mesh that floor, the beams are broken into pieces, right? Now, if you use the design beam, every beam would be treated as an individual beam elements. Now, if you design it, it would be like, okay, 3 number of 16 mm bar for the top. Nearby one, the demand might be less. It would be like 12 bar, maybe 2 numbers. Next would be like again 16. So there could be different kinds of steel detailing for each and every broken pieces. Now, can you lay it in your practical side? You can't. You have to maintain some continuity, right? So that is the reason. In this case, you have to use your engineering judgment and manually pick the most optimum one. But the point is, as for his case, most of the cases like pipe rack or any other industrial structure, which we don't have this kind of requirement of slab or plates, then this module is very good. Yes. So, but if you have something like slab system or floor system, which we want to deal, then the best way is to use advanced concrete designer. Okay, great. Advanced concrete designer. I'll take some time to explain this. This is a very interesting topic, this one. And I move forward. Yeah, you can call this. The reason being, there are several reasons for this. First of all, as I mentioned, one of the simple examples, here we are designing with respect to the physical member as a complete continuous physical member. Also, we can do a lot of other checks. For example, crack width check. We can do the detailing of all those beams very effectively. We can generate the bar bending schedules. We have advanced seismic resistance options to define as a ductile design. So, in short, just to summarize this, instead we have two different concrete design approach. One is we call it the batch mode, and second is we call it the RCDC. So why I have pointed out this, batch mode is the inbuilt one that comes with STAB. Okay, this is mostly for maybe it's for industrial structure, pipe deck, or any other structure. But if you're into the building, then always try to use this RCDC because a lot of advantages will. RCDC, another name of this RCDC is Advanced Concrete Designer. Okay, we'll see it once we start working on this. Okay, let's see where we are. So in a nutshell, we can see that, okay, for foundation, we have STAT foundation advanced. In a same project, we might have to use so many products, okay? Not only STAT, but other products that are associated with STAT, right from small little connection design to detailing and so on. So everything that we can see that all those peripheral products, these are all covered under a single licensing system. We call it a structural work suite. Okay, so structural work suite is not a product itself. It's a single offering or the license we are providing to the user to give the access to all those products. Okay. The reason being, instead, we no longer deal with stat alone. We are dealing with a complete total solution, and everything is well integrated, interlinked. So under structural work suite, we have these kind of set of programs. Okay, so many structural solutions we have apart from stat. So you'll get all of them under this single license. Any question? Okay. I'll go a little bit fast here so that I can open the model and discuss, because Ronki still both of them we have to cover. Those who are new to the stat, let me give you some of the differentiator. Okay. First of all, it's a time-tested product. It's not like product we have developed overnight. Okay, it's been for 24, 25 years and so on. It has got the input editor. Okay, I think every one of you are aware of this, right? Input editor in stat. If not, let me give you some idea. Like input editor is nothing but another approach to control different modeling or different analysis instruction through command prompts, through different syntax. Okay, for example, you want to apply some partial moment release to set of members. You needn't have to go to like select the members graphically. You can select the member from the input editor, define the member number, and define like MP 0.99 or 95. Everything will be automatically assigned to all the defined members. It's a very handy tool, and it has got advanced entitlement procedures. It's a graphical user interface, is very intuitive. Open architecture for customization. Any one of you are using the OpenStat, by the way? Not yet. You've heard of, right? Did you ever hear?
Yes.
OpenStat? Never used, right? If you want any separate training on OpenStat, please let me know. We have I also work a little bit on OpenStat because it's more on this programming. It's a program through VBA. It's a kind of open architecture. In case any of the design codes or any of the features which are not provided in stat, for example, just say, for example, if your local Indonesian code, just for a sake of an explanation, it's not implemented in stat, how you will deal with that? You can analyze everything in stat, and as usual, you work with your Excel spreadsheet, right? You didn't have to manually pull those. You can automate. A lot of commands and everything. You can pull the information directly through the simple set of VBA computer, language instruction, and you can automate all the simple workflow. And this architecture, we call it the OpenStat architecture. Okay. Okay, so we have multinational design codes. We do have physical modeler, powerful integration. As we mentioned, we have a good integration with other products and suitable for any other structures. So what are the different structures we can expect? It could be building, it could be power plant, transmission tower, bridges, industrial shed, heavy engineering, renewables, civil infra, oil and gas, heavy engineering. So these are few of them, but the list is endless. The reason being, we have a lot of option to customize. Okay. And for example, if I take the bridge, we have so many options to model the bridge. We have different material we are supporting as far as the design code is concerned. And most of the international design codes we have. Okay, from the structural analysis capabilities point of view, so we can handle both static as well as the dynamic. Okay. Now, in the static, we can further classify as a linear and then non-linear. Okay. Non-linear, mostly the geometric non-linearity we are capturing. If you're doing the dynamic analysis, we have different options like response spectrum, time history. Response spectrum is mostly for the seismic precision design, which is a codal-based approach mostly. And if we are into the dynamic analysis, what type of different structure or different scenarios you can handle. So we have different options. It could be forced, it could be unforced, it could be periodic, it could be non-periodic. For example, you want to do the machine foundation. You want to do the blast analysis, earthquake analysis, footfall analysis, and so on. So there are different types of solvers we have by which you can attain all those different requirements. So this is the summary of the analysis capabilities. Now, in your day-to-day life, which type of analysis you need? Just let me know. In your structure or in your project. Nonlinear? Nonlinear. Geometric nonlinear, right? And how about the dynamic analysis? Okay, now nonlinear, someone you have mentioned, right? Yeah, so what type of nonlinear? It's a P-delta analysis, large deformation. Yes, it's a nonlinear, right? Exactly. So yes, so there could be different scenarios. It could be building. We do have the P-delta. Even if it is not building, if it is for steel structure, because steel structure is mainly steel member is mainly slender, and there could be a lot of imperfection. Imperfection is always there, but the second order effect for which we are doing the P-delta analysis to capture the second order effect, it is very much susceptible in the steel structures. So yes, that is the reason if you go to the AISC code, they almost indirectly mandate to do the direct analysis, which is essentially a P-delta analysis doing at the background. So yes, these are all the nonlinear analysis. But if you're in the normal structure, maybe you can have this one, so linear static analysis. Yeah. Most of the cases people do this one, but apart from this, for some specific reason, you can have some advanced set of analysis requirements. And we have another offering called StatPro Advanced. If something is not being solved through the basic solver, then we do have something called advanced solver like geometric nonlinear analysis, nonlinear cable analysis, dynamic analysis, synthetic dynasty analysis, pushover analysis, and so on. So for any kind of advanced structure, I will highly recommend to go for the StatPro Advanced. Okay. So this is the evolution of StatPro. Like from 2007 onwards, we have different versions and different editions. BATCH, Select Series, Connect Edition, and right now we are in 2020-23, but later on we have 2024. So who have installed the latest one? I think some of you have installed 2023, right? So every one of you have 2023? No? Okay. Now, from here to here, maybe if you go to some old YouTube videos, a lot of YouTubers are there, they will show you with the VADI. VADI is a very older version. Right now, we have 2020 onwards, we have migrated to Connect Edition than 2024. A lot of changes we have made it. So anyway, Connect Edition and all, most of you are aware of. Just to give you some of the quick, differentiator here, it's a physical modeler-based approach. And solver is 64-bit solver. It has the integration with Edina, and all the international design codes are available. It has got the steel autodrafter, steel connection design we have, and advanced concrete design. Okay. Apart from that, there are a lot of other differentiators. Few of the newly implemented code like ASC 360 2022, we have ACI 31819, IBC code, and code form code also we have added. Although these are some of the newly added, okay, but please don't stick to that. We have so many other international design codes implemented. So yes, so 11 incorporated 2022. 2022 ASC? Yeah, ASC we have. Oh, okay. Yeah. So yeah, this is just a quick comparison. If you're holding the older version and newer version, we have statistically found that the newest version is much more faster with different configurations. iTwin Synchronizer, this is what we have asked for, like Beam integration and all. And this is the platform to which you can integrate with other products like Revit, it could be Tekla structures and so on. Maybe after this end of this session, I can have a small video on this. But this is not a software, this is a small in-house application. It's based on, we call it digital twin, by which we can integrate between different products. We can pull the information, not only the loading information or the sketch, we can import a lot of information like section sizes, material properties, it's a release condition, so many things. And this is the interface that it is connecting with through this iTwin platform like STAAD, Open Building Designer, Revit Structure, SACS, AutoPipe, Bim-Structural System, ProStructure, ProSteel, and so on. Yeah, if you want to take a snapshot, you can take it. Let me give you a quick workflow demonstration on this. So if you have open STAAD Pro, did you try this iTwin Synchronizer in STAAD, by the way? You have tried. Okay, from which product you tried import or export? Not analytical. Means which are the other products like ProStructure, SACS, Revit?
Only Sapro to Revit.
Or to Revit. You have tried, right? Okay, fine. Good. So yes, those who are new to this, just to let you know that, yeah, we have a different set of integration. Yeah, sometimes if you find any kind of issues, please let us know because we are still evolving. Within this iTwin Synchronizer, you have the option to pull different options. Like, for example, I think this is a Open Building Designer. This is an architectural drawing, and I think this light is too strong. And we can import the building. So let me just pull this a little bit. Yeah. So you can see that this is an architectural drawing, right? So this could be your building or industrial structure, anything. Okay, I'm just showing it on this normal building structure, and it's a finite element model. Now this model, you can visualize, you can see everything in this iTwin Synchronizer, and you can just include or exclude any of the information you want to discard. And this skyway view is very effective to quickly see, like, if there is any clash or if there is any kind of overlap, everything you can just visualize properly. So once you are happy with that, after putting those information, you can import it in STAAD Pro Physical Modeler. Okay, this is the physical modeler. And here you can see we have imported it, and it consists of all finite element information like meshing and everything. Let me just drag it a little bit just to show you on the mesh. It's a kind of very fine mesh. You can change the mesh density and everything. I go a little bit faster, taking a little bit of time to create the analytical model because a huge finite element information it has to generate. Now, once you are successfully done with this, it will generate a complete analytical model for me. So here you can see it consists of thickness, it consists of connections, everything, whatever is there in the software from which you have imported. So any question on this?
Next.
Yeah, please.
How to connect the physical model to analytical models?
Okay. I'll come to that. Right now it's an analytical modeler and it was imported in the physical modeler, right? So there are two different modes. Maybe if I show you the live model, I can show you this. Any one of you have used the physical modeler, by the way? I think you have used, right, using. Any one of you? Physical model. Okay. So this is the chapter that we are coming. Physical modeler is a very important feature that we have added in Connect Edition in 2020. Okay. Now a lot of users have been working on STAT, but they don't use the physical modeler. Yes, it's absolutely optional. Means if you didn't have to use it, but sorry, it can help you to enhance your experience in modeling. So what exactly is the physical modeler? Let's see. So this is the model we really see it in our real life scenario. Okay. For example, this table, for example, can we see any meshing, any nodes? Nothing. We see a very continuous solid elements, right? Solid means a simple single element. But for the software, they don't use this one. They will need some analytical information like meshing, nodal information, connectivity information, a lot of other things. The point is, if we use the meshing in the normal approach, we can do it in the normal analytical modeler, but there are a lot of different meshing standards and quality we need to ensure. First of all, the connectivity issues, mesh quality, it should have a very good aspect ratio, and all those connectivity and quality issues will take a lot of time for an engineer to generate this. So that is the reason if you model it in a platform where you just need to define, for example, this table, I can define all the 4 corner nodes and thickness. And if there is any column or beam, program would internally generate and establish the connection. How about it? It would be a wonderful experience, right? So we can model it in how we see it in the physical sense. That's the reason we call it the physical modeler. And it will generate the analytical modeler like this. You can see this, all those meshed footing you would have generated in the analytical modeler. You also know that the analytical modeler, we have something called mat foundation, so plate mat and so on. Plate mesh, everything we can do it in the analytical modeler, but you can leverage the power of the physical modeler for quickly modeling this. First of all, what are the different advantages we have? First of all, this, for example, this is a plate bracket, okay? Now, if you want to model it in the analytical modeler with those small little perforations, it will be very painful. It can be done. I am not telling that it can't be done. It can be done. Now, those who are new to this might be wondering, what am I speaking? What is physical? What is analytical? Let me give you some background of this. STAT, we have 2 different approach. One is analytical modeler, which is a very old one. Means since it has started, its graphical user interface, this is there. Then we have physical modeler. A physical modeler approach we have newly added it. The reason being to enhance the quick finite element modeling with the ability to make any changes if it is needed. So this one, for example, if you want to mesh it, how will you do it? Analytical modeler. What are the different ways we can use in analytical modeler? Anyone? What are the different options we have in the analytical modeler for meshing? Normal plate mesh, just select the plate, right click and generate the mesh. But this is a very basic one. We call it the structured mesh. Second is unstructured mesh, which is, we call it parametric model. Okay. So in the analytical modeler, you can use the parametric modeling for generating the mesh, but still it has got some limitation. I won't say it's a limitation, but it is a time consuming. So better if you go to the physical modeler and know quickly modeling it. For example, all you need is modeling just the normal components. This bracket plate, this one, this stiffener, and the holes. And this mesh will be generated by the program. You can see the quality of the meshing. Small little mesh. If you take any of the mesh, these are very close to equilateral triangle. Aspect ratio is very good. Wherever there should be some expected stress concentration, it has increased its mesh density, established a proper connectivity. And on top of that, say your client say that, okay, this bolt diameter is, you have modeled it with the 1 inch, and that they demanded that, okay, you change it to 2 inch. Can you do it in the normal stack? Just change this. It's very difficult. Means I would say almost impossible. You need to delete everything. So if you go by the physical modeler, you can easily go back to the physical modeler interface, change the dimension of this hole, and come back to the analytical modeler. Every meshing and everything will be automatically readjusted by the program. That's the beauty here. We have the flexibility. For example, here, this is a building, and we have some opening. Okay. This is modeled in the physical modeler. And all of a sudden, just imagine that my client says that, okay, change the shape of this opening from rectangle to triangle. Okay. Now, if I have already more meshed it in the physical normal way, like analytical modeler, I have to delete everything. So yes, we can come back and we can go back to our table in the physical modeler, change the basic dimension, just the corner dimension, reduced it to, you can see, triangle. Triangle is not practical, but just for this explanation, I have just shown this. And if I come to the analytical modeler, you can see the mesh and everything is automatically adjusted. So I didn't have to delete anything. I didn't have to recreate anything. Okay, so that's the beauty of physical modeler, especially if you're working with the fine human model. Okay, any question? Yeah.
Can we set the mesh, not the parametric model, but the square meshing?
Square meshing here?
Yes.
Not square exactly. These are all quadrilateral. And wherever it is required, you can see small little squares are created. It's not square, you can see it's a quadrilateral meshing. Because see, this is a triangle, right? How if I have to model it a square, at certain point of time, it has to just change its orientation and insert some triangle, right? That is the reason it automatically reorients and adjust it. So why you need the square rectangular section or rectangular meshing? For designing?
Yes.
For designing it within Stat Pro, right?
Yes.
Yeah, I know that this is the common reason, and that's why you didn't have to do that. I'll show that. How will you design this with square? First of all, if it is obviously you are not going to make any triangle here, but if it is a rectangle, then obviously program would automatically create. I'll show you just one more. You can see squares. This thing you are not going to design it here inside Stat for building. If it is say, go to the RCDC. RCDC will design you the shear wall and everything. If it is for slab, I understand where you are coming from. Your question is a very pertinent question.
So isn't that one complete
Designer, yes.
that included in GSS package, or
Because right now I'm open the my stack.
I cannot click the
Is it? Let me see. He has asked the question. It's a very interesting question, and with this, I'll try to explain you. These kind of things I want to discuss here.
so there is a warning here that funds complete design
The treatment. Yeah, and this not found. Yes, not found. Is that advanced or just the basic? This one, yeah, basic. I think that's nothing.
Oh,
Yes, yes. Yeah, it comes with the separate laws.
okay.
But there are some other things you need to consider while you bring it to artists. I'll just connect with everything. So stay tuned. Let me first come to his question. Okay. So he mentioned something like rectangular meshing. Anyone of you are working with the finite model meshing and everything. At any point of time, you need that. Okay, be it building or non-building, meshing is very important. I've seen several users simply model this kind of plate. There is a column and it doesn't mesh properly. Even don't mesh, just apply the load. It's completely wrong method. If you mesh it rectangular like this is a plan view, top view. Okay. I suppose you're asking like if it is well defined rectangle, then you can design within StatPro. Is it the purpose? Plate design, right? Okay. When you're designing this in Stat or you're in your Excel spreadsheet, where you're designing it? Excel spreadsheet, right? Yeah. And I understand why you ask this question, because here the reinforcement you want to put it like this, right? In the global direction. Am I correct? Now, if I bring it here, then its local axis orientation would be everyone will be oriented along the same directions. Okay. So it is very easier for me to design it in Excel because all of them are oriented in the same directions, right? Now, if we insert, this is called structured mesh. If you do the parametric modeling, you can expect this. And if your external boundary is well defined, but it won't guarantee that you would be lucky enough to get a well-defined, those sections like this. Say, for example, you have a column here and use the parametric models. So what program would do, because this is called control point. So to consider this control point in the meshing, what it will do, it will try to, because it is automatically done, try to make the meshing like this. Something like this. Now, you can see here all the orientations of the local axis systems are changed. If you design with this moment locally, because all the moment that you are taking it from StatPro, I suppose you are taking the local axis moment, right? So the designing against the local axis moment, the reinforcement will be like this, maybe like this. So practically you can put it, but what is the solution for this? You have to convert all the local axis moment to what? To global axis. Now this conversion, you might do it in Excel spreadsheet, or else you can pull it from STAT itself, because STAT also reports the global axis moment. There is something called, I would recommend you, if you are working on Excel spreadsheet, I'll recommend you to use this one. I think you know this. Wooden armor moment. Wooden armor moment is additionally taking the twisting moment, and also you can define the orientation along which you are going to put the reinforcement. If you see any formulation for converting local to global, this is basically have a very correlationship with the wooden armor moment. So the point is, if you are in the Excel spreadsheet, you have to do with respect to the global axis system. So you are not lucky enough to get the well-defined, division. But if you are doing it in, say, RAM concept, okay, RAM concept is another product which we are designing it for CAD Lab, and it is integrated with StatPro. All the global axis conversion of this global axis system would be done internally. So you didn't have to worry about this. You just need to define that which direction you want to define the reinforcement. Okay, same thing for the STAT foundation also. Okay. There is something you might have seen that inside function, there is something called generate the moment envelope. When it draws some line, while we draw in the line, we are defining that, okay, along this direction, we want the reinforcement to be established. Okay. Yeah. Anyway, so next is, before I go into that, we have seismic options for the building industry. We have response spectrum, we have time history analysis capabilities. Okay, so those in the building industry, please take a note that we have a, see, STAT is a very big chapter. In the 3 hours is very difficult to cover each and every detail aspect of this. So just to let you know that we have a very advanced response spectrum analysis feature and time history analysis by which you can simulate any kind of dynamic simulation of the structure. Calculation of base shear in STAT. This is a common question. If you want, then you can take a snapshot because you won't find it in our help manual. A lot of users come back like, okay, our base shear is not matching with our expectation. Okay, you need to see that these 4 parameters are properly calculated or not. Then you can assert it. Take this snapshot because it is very helpful if you do it for the dynamic analysis of the building. Because I was in support, so many users are doing this building analysis and found out the base shear is 0. Why it is? So then we noticed that mass participation might be very small. Spectral acceleration for this mode is very less. So we need to see that all those factors are within our expected range or not. Okay, now let me, by the way, how many of you are doing the response spectrum in STAT, by the way? No one of you? Okay, then I should not jump into this directly. While I'll come to the modeling, I will just show you. Just to let you know that we have auto mass model generator. I don't know if ETAPS, I am not comparing with any other software. Just to let you know that if you have the static load case, like, or the gravity load case, like dead load or live load, you can ask the program to create the mass modeling directly out of it. Previously, we need to copy it and paste it for self-weight X, self-weight Y, self-weight Z. We didn't have to do right now. We have some automated mass modeler generator, but you need to mention that, okay, these are the gravity load, which you will take it as the inertial information. You can see on the right side, everything was automatically created by the program. I've taken it for the very small model, but if it is a huge model, it will take a long time if you go by the normal procedure. Anyway, some advanced dynamic analysis, reads analysis. I'm not going into the detailed discussion of this, but just to ask you, in any other software, are you using this? Or maybe in your industrial structure, also, if you're doing the dynamic analysis, you might need to use in some cases. Okay. Now, this would be very much helpful, especially pipeline and all. If you're doing the dynamic analysis, it might help. Say, for example, there is a building like this, normal building, and you have modeled some mounting structure here, maybe for some stand or something like this, and you model everything like pipes, everything, or maybe some antenna, steel antenna, and something like this. Now, what happens if the structure is very complex? There are some elements which are not that steep compared to the main structure. Now, when you vibrate it, for example, let me show you this one, for example. When you vibrate it, those antenna will fluttering, just like your flag, pole, and something like this. Now, you might be wondering, like, okay, I'm doing the dynamic, and you can't remove it. Also, you might want to model it, maybe the part of, for example, mezzanine floor and all. Now, what happens? Your entire structure is very steep, but that connected component is not that steep. Okay, so you would end up seeing that, okay, if you do the eigen solution, some local modes are generated, for say first 30 or first 50 cutoff modes. Now, is it okay to accept this? No, because these carry very insignificant mass, very small mass. What code says that? We need to consider that many mass which will constitute the cumulative 90% of the participation, right? That means we need to consider all the mode so that my entire structure, 90% of the mass is being excited. So you might see that by the normal analysis that, okay, for first 30 or 60 modes, I'm only getting my antenna fluttered, but not the normal structure. So what we'll do, we'll ask for some higher modes, maybe 200 modes, 300 modes, cutoff mode shapes. More you ask, more it will take the time. And it will sometimes for a big model, it will take 2 hours, 3 hours, okay, to reach this 90% target. So there is a method called load dependent bits method. The purpose of this is to ignore any kind of modes which is not carrying significant mass, which is called load dependent bridge analysis. In case you are working on any steel structure specially, try to change between this normal eigen solution and load dependent bridge. It will try to solve your analysis much more faster in case you experience some local modes like this. So let me show you like if I have any, yeah, this one. This is the same model. You can see this 90% target with the load dependent rates. I have got it after 45 cutoff modes. And in the eigen solution, even after 100 modes, I could not reach 90. So this is just to tell you, see, this is not a class of dynamics or anything because we have to cover a lot of things just to give you like differentiating feature. If you have any question, you can ask me. Science response spectrum. Anyone of you are aware of? Do you want me to discuss this a little bit? Do you need to use why? By the way, any other software? Do you have this time response spectrum? By the way, you have, right? Now he has worked on this. So what happens? Just to give you some idea, like in the response spectrum analysis, what happens after you perform the eigen solution for every mode you are solving, right? We call the eigen frequency and everything. Now, responses of every modes are fetched from this response spectrum curve, right? Depending on the natural time period of that particular mode. Now, there is something called combination method, CQC method, SRSS method, right? So these are basically something like this. If I want to show something. Something like resultant would be R1 square, R2 square, R3 square. CQC also, there is some expression where square is involved. R means the responses. It could be reaction, it could be displacement, it could be forces. For example, if I take this simple portal frame one, for first mode, if my reaction is upward, let's say it's positive. Second mode, first mode, let me take second mode, reaction is negative, let's say R2. Third mode, again, reaction is positive, means upward. So every other mode, we have a direction of its reactions, right? But when you are finding the resultant one, you are squaring those terms, right? So negative sign is lost. And again, you are operating with the square root. So what you are getting, some unsigned quantity, right? Absolute quantities. And that is the reason in the response pattern, you can see both the sides, you can see this portal frame is having a compression. This is nothing to do with that. All the other software has to go by this numerical procedure. But there are some scenarios like, for example, you are doing the footing design. You need to know like, okay, whether there would be uplift or not. So a lot of engineers requested us, why don't we use something based on which we can evaluate that, okay, whether it would be in tension or compression. So we told that, no, we can't do because code itself says this method. But there are several literatures which says that yes, you can take this response quantities, but the weightage of the mode you can take. Which mode? The fundamental mode, means which carries the maximum mass participation factor. So what program does, it takes the sign of that fundamental mode and assign it to the final response quantity so that you can at least understand the sign, tension or compression. So we can do it in StatPro. Anyway, so any questions so far? Anyone? Yes.
I'm going to start. So how to set the level of the top of structure if we get first in Revit like that. So and we transfer to start and the connection of the bit column is in the same row.
Mm-hmm.
Yes. How to set the allocation of the top of structure?
No, means you are exporting it from stat to Revit or importing it from Revit to stat? Which one? Revit to stat, right? See, I don't have Revit because it's Autodesk product, so I can't open Revit, but I might have a similar workflow on this Revit. Just one moment. But let me show you this one, because please let me know if my topic doesn't seem to cover your requirement. Please let me know. As I mentioned you, the vast subject, steel, concave, dynamic analysis, non-linearity, I-twin capture. So it's not possible to cover each aspect in this limited time. So every one of you might have different requirements, right? Let me show you this one. If I have something. I think this is for similar to stat. This is Revit. I have imported in RAM structural system, another product. Because Revit I don't have, so I can't tell that how to operate in Revit. Maybe those who are into Revit, they can use. But the interface, once we bring it in ISM, from there on, we do have the control. Previously, I did have Revit, but after all, we didn't have any Autodesk license, so we have to, from IT instruction, we have to do this. Okay, this is for RAM structural system. Let me see if I have something similar to this on stat. If it is stat, let me see. Yeah, it is, I think, on stat. So let me show you and see the workflow if it is sufficing your requirement or not. This is Autodesk Revit, okay? I can share you this video, okay? This point, if you can further revisit this entire process. So let me play this. It's a long process. Yeah, I'm just it a little bit. It's a bit interface. You can see all those joints and everything you're asking. Yes. You can find it in this video. As I don't have Revit, so I can't open Revit and show you, but I have recorded it before that. Every steps are recorded here. Long videos. Yeah. This is I-twin in stat. This is how we have imported in StatPro in the physical model. And in the physical modeler, you can make the changes like mesh density and everything. Further, you can take it. There also, you can make some changes in this ISM modeler. A lot of things, if you think that, okay, I want to discard or if you want to include, you can do this. It's a long video, around 5 minutes, entire process we have discussed. Maybe I can share you can see each and every steps, which may give you some better insight. So this is the entire work. I have also shown it. If you want to make the changes in stat and again take it to Revit, you can also do it. So it's a two-way traffic. So please remind me after this end of the thing, I will share this kind of things. There is another one, another example I had from Revit to stat. We had Revit license. After that, we have discarded the Autodesk license because of some IT compliance. So, yeah. Okay, I'll share this information with you. You can get everything information. Okay, now can you take a break? Then we'll come with some live model presentation, maybe quickly with the building and then the steel. Okay, how much time we have? 1.5 hours, can it be?
Nah, udah ada. Udah ada. Oh. Painter udah bisa di-install? Lagi ya? Oke. Gimana? Udah di-install?
Enggak, aku udah punya kan. Aku kira beda.
Sama.
Enggak.
Nah, tapi versi 23 lebih tinggi ya. Dari kantor yang install.
Enggak.
Kalau saya lebih ke arah MC. Oh, itu. Tengah perak.
Kalau pakai ini juga ya, start bisa.
Gimana, Pak?
Bisa sih start.
Ya. Iya, itu saya.
Harus
Ya,
bikin
bisa
folder
lebih.
dia awalnya dulu.
Ya.
Jadi saya lihat di helpnya BMD, Pak. Kalau kita nanti punya bisa start pro ya, start pro biasa ya, bukan yang kita dapat beberapa fitur atau barang yang lain, Pak, ya, software lain. Start provision,
Sudah sih.
Dari KPT ya.
iya.
Oh, saya coba cek dulu ya Pak ya.
Tergantung tag itu apa gitu gitu kan.
Pakai CSS ya. Sehingga saya perusahaannya Bapak pakai tipologinya yang CSS sih.
Yang mulai atau yang subscribe? Subscribe.
CSS kan.
Iya.
Saya cek.
Kerjaan proyek sama aku pakai
KPT di 3 orang ya, yang belajar.
orang
Ya, mulai besok.
nanti, Pak.
Oh, nanti siang ya.
Nanti jadi.
Ada berapa itu Pak? Berapa user staff di KPT Pak? Saat ini?
Banyak, Pak, bergerak terus lah.
Semua bergerak terus ya? Oke. Yang subscribe ya?
Apa?
Yang subscribe ya? Yang Virtuosity?
Iya.
Kalau Pak Edi tahu Pak? Pak Edi orang Peterman ya Pak? Pak Edi siapa sih? Lihat orangnya orang Peterman. Kalau saya bicara sama Pak Riki ya Pak Edi.
Oh, ini
Kalau Riki itu Pak Riki
di GM-nya infrastruktur.
itu peran. Pak Edi itu Pak Edi Soeharto.
Wah,
Edi Soeharto. Dia dari Peterman ya Pak?
manajemen,
Oh, PMC.
nggak project manajemen.
Oh, manajemen. Oke, oke. Ya.
Bisa
Nggak bisa.
dari awal ke KPT. Wah, saya baru masuk. Jadi, sekarang 2 tahun. Tapi kan nanti ini dunia kan ya. Oh, itu. Enggak deh. Sekarang mulai lagi. Oh, enggak. Konstruksinya apa? Mungkin ini kan udah selesai.
Okay, so let's quickly start. Okay, there are a lot of things we'll discuss while we will cover our session. By the way, for the user on the steel industry, just want to give you some idea, quick idea. Income from oil and gas. Yes.
Neighbor relation.
Yes.
They are asking about how to make solution for error when
Arrow.
error.
Yes.
They have error when convert physical analysis to physical analysis to
Analytical model.
analytical model.
Yeah, there could be n number of different errors. So I need to know what type of errors they are getting. Let me come. Let them come. Please don't shy. be shy as much as possible. Just ask me. Okay. I'm repeatedly asking, like, if you have any questions, please ask me. Okay. No, after that, yeah, let me finish this. And just call it start. Okay, so next is Advanced Concrete Designer. As I mentioned at the very beginning, we have two different approaches. One is within StatPro, we have building concrete design module, and also we have separate design module. We call it Advanced Concrete Designer. Okay, so let me give you some idea, and I'll open a model and just show you the workflow for designing. First of all, the design codes that we have, most of the standard international design codes, including the ACI, Euro, Philippines, India, Australian, these codes are available. As we understand that mostly we are into the US code, so the ACI code, most of the standard versions are available. Okay, now who is having the question on this physical modeler, analytical modeler? Who was having this question, by the way?
Yes.
They asking about the. They means from here or from online?
From
Online. Okay, 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 okay. I know what is the most common error. I'll come to that. Don't worry. So for the concrete design, we have so many options in the RCDC. Okay, so please pay a little bit of attention here. First of all, we have a option not only for designing, but a very good option to detailing as well. Just to design, if I give you like AST required this much, oh, it's a headache, right? You have to convert it into number of reinforcement, shear bars, draw this by sitting with your draftsman and generate the drawings. A lot of tasks you have to do, right? But what if we do all those things automatically by the program? So that's the point here. Drawing and detailing. So it will generate a very well detailed drawing. Okay, well detailed drawing. So the detailing would be very top notch. This is a cross section of a shear wall. Now, just to add you, a lot of user might be interested to know whether the boundary element of the shear wall is designed. Yes. For example, this one. Okay. This is a very big differentiator we have in RCDC. So be it rectangular column, circular column, doesn't matter. Say, for example, you have something like T-shaped column or I-shaped column. So can you design in normal stat procedure? Because the normal inbuilt stat, we only have rectangular and circular. But as we know that in the building industry, we might come across rectangular, L, T, I, even any other shape like hexagonal shape and so on. So this was a very long-standing requirement from our user that whether we can design any kind of arbitrary shape, okay? Any kind of polygonal shape we can design. The reason being we are designing it from the very first principle using the interaction surface. And this is the column design. You can see the detailing. And believe me, these detailing are very rich. Maintaining the proper lap length, its height, its distance, spacing, all those zones, everything is well detailed. Even if it is for beam, you can see the detailing after designing. very rich. I think why can't we hide this? I don't know. Or how to hide this. Anyway, this is a bar bending schedule. So this is also a very painful task. After you design, you need to generate the bar bending schedule like cutting length and all, right? So we have this product by which it will also generate the bar bending schedule, including the cutting length and all. Okay, those who are from concrete industry, especially building, they will find it very useful. Slab and staircase. We can design. And the reports and BOQ, the bill of quantities. Okay, now let me open a quick model for you. Let me see if I can have. For steel structures, I'll come later after this. A lot of interesting thing I have to discuss. For example, effective length factor, which is I think very interesting, right? So I'll just have a very intense discussion on this. Okay, please stay tuned on this. First, let's quickly show this concrete workflow because we have some 1 hour. I have requested to extend by another half hour. So this is in STAD, right? Now, someone has asked like the question that they have used a physical modeler, and while they have, you have also asked, right? While you have come to the analytical modeler, you got some error message. I don't know the error message that you got. First of all, let me discuss this, then I will come to that. Just hold on. This.
Ini Bapak Ibu ya, nanti kalau ada pertanyaan, nggak tahu cara ngomongnya, sampai ke sini, ya, gitu ya. Jadi biar lebih ini ya, biar ada sesuatu tuh apa, unek-unek gitu bisa sampaikannya. Ke sini ya. Ya, siap bantu gitu ya, ya. Bapak Ibu nanti nggak salah ragu. Bahasa Indonesia juga Pak Rasul ya, Pak Rasul belakang. KTP Pak, ya.
Something encouraging.
Yeah.
Well, I can't understand. Okay.
Jadi ini Pak, sesuatu yang terkait sama function dari technical dari satu ini. Jelas ya Pak?
Okay, so this is physical modeler. Okay. Now, I'm not going to model it right now because it will take some time. This is a model I already have. Now, if I go to analytical modeler, I can quickly go there, right? I can again come back. And if I want to make any changes, first of all, let me show you. There is something called analysis model. Just one moment. Mesh size, I can change it to triangular and make it like 1 meter, for example. Now, I don't know what type of error, because here also you can see error and messages are reported. If there is any specific model specific, you can just send it across to me because we need to investigate this. But in most of the cases, there is a very common error. Let me discuss it. Let's first create this one. If I go to analytical modeler, hold on. So you can see this time I have reduced my mesh. Okay. As mentioned, structured mesh would will if our core location is good, it will well shape. Okay. Now, in many of the situations, if you come back to the analytical modeler, if you want to make the changes from here, you can see something is great. Okay, you can't add anything, so don't get panicked here. Okay, you can open the actual physical modeler, and there is something called drop physical to drop bit, right? Okay, if you drop it, then the connection between analytical and physical would be dropped, and you can further see all those things will be active in the analytical mode. Okay, so before you drop it, just save it as by different numbers mentioned before. You can go it in the future point of time. Okay, and regarding the any specific error message, as someone of you, if you are concerned with here, it could be some software related issue, model specific issues. So you need to just send it across to me. I need to, along with the model, investigate it now. Okay, now let's go to our stat model first. If you're working in the building industry, building model, I'll highly recommend you to model it in the physical modeler, specifically this shear wall. Why? Because this shear wall can only, these are model in the physical, either in the physical modeler, or else if you are doing modeling it in the analytical modeler, make sure that while we generate mesh from here, we show this while you generate a mesh from here. I'm not going to add, I want to tamper this. There's something called type all and into a wall. Okay? Then it will identify the wall. Or else you would be like, you know, you would be kind of difficult making RTT to recognize this vertical wall as shear wall, and you would be very much why RCTC could not identify those shear walls. The reason being, either if you're working direct in the analytical model, all defined as a shear wall. quick idea on this. Please share my screen. Okay. Okay, which one? This one? Sure. It have its ground. This chapter is important and interesting. The reason being, this is the question I have come across. So thought of like just some every system can be added a different diaphragm. Let's say, for example, as I mentioned, if you model it normal framing system, just not modeling the data, it follows certain structural requirements. And important thing is rigid or semi data elements. Kind of demonstration in the later one. This is the displacement is such that even though there is an opening, it moves as a single rigid body movement. Okay. Can you see any internal displacement within this? Because we are assuming that this total system will move as a single body movement. Okay. First thing, that this float system would behave as a rigid flow diaphragm or the semi-rigid. That's the $1 million question. Now, as he has rightly pointed that there are some disadvantages and advantages also. So take all those dreams, right? Now, at cost of that, we need to first understand. Let me. And this is the band about its own axis in plane direction, right? So it is not rigid. Okay, it is semi-rigid. Okay. Now, how to, yeah, the one. In plane is your moving. So you like this or not. So if you go to the code, there are some recommendation. Okay. As you are in in Indonesia and it's the international design course, you can go to AC code. There are some kind of demonstration or some kind of specification they have defined for flexible, which is a doesn't have any set all and some span to depth ratio. There's some kind of guideline. If there's no horizontal irregularity, there's another condition. And you need to just make sure that the maximum deflection should not be more than 2 times the average. Then only you can consider it a rigid flow diaphragm code, and you can accordingly determine that whether it falls in the rigid or not a rigid diaphragm, right? If it is a rigid flow diaphragm, then simply you can model it without the plate elements. Okay, without the plate elements. So I'm not the Indian code reference, so that's just a similar kind of things. Okay, now diaphragm instead and semi-rigid without modeling the physical plate elements. Without modeling the physical elements, just you find the rigid and find its level. Okay, very straightforward. When I go to the model, I'll show you. I'm stuck right now. Another reason would be this one. You can see this open structure. You can't the rigid flow diaphragm here, because this will plane deformation. Okay. Even if there is a cutout which is having significant span, you should use it carefully. The ocean undergo in-plane deformation. And also another disadvantage is if you use, if there is a bracing like this, you can't get any forces in this horizontal bracings. Okay, so and if it is transfer, that means the load is directly falling on the slab, not on the column. Obviously, how you distribute the load. So in the nutshell, the million dollar question is, shall I go for rigid diaphragm or not? And to understand that the meshing, if you are not defining the rigid diaphragm, that means you have to use the plate element and mesh it, and it needs a huge computational effort. So the conclusion is, the semi-rigid diaphragm is realistic and most accurate way to capture the behavior of any diaphragm, irrespective of L requirement. On the other hand, rigid and flexible floats are two extreme conditions which are assumed to be faster and numerically stable compression performance. So eventually, use your engineering judgment by assessing the benefit and the effort involved in modeling analysis time when the term qualifies for and semi. So a detailed webinar on this. I've just gone through the overview, some case studies, some modeling I have already discussed. I can send you the link if you want. So depending on that, you can model it without elements, right? If it doesn't fall in my let's see here. So here you can, I have not defined it. I'm assuming rigidly by checking different aspect ratio and element. Also mention, please note that if it for down, as I have not the physical slab here, I find the diaphragm, finding the diaphragm height. Okay, just I define the height of the float. Diaphragm has been assigned here. Okay, all those levels. Okay, so I have already performed the analysis here. Also, one more thing, I go to this advanced concrete designer. Are you aware that we have some automated combination, load combination generator? Are you using this, by the way? You know why? Any reason? Because this is a very powerful model. This automatic load combination is something like, first of all, if you want to generate based on the codal approach, quickly generate. For example, it's a, if I click on generate, all the possible you want to do the industry where we have a, you can use this edit auto load combination. You can create design rule combinations. You can see here, I can go to log. Seven, five, and so on. And you can all those different stuff comes and give it a name commit, and you save it. Once you define it, I think it's a custom code, many codes. And next time, whenever you use load combination, custom codes should be generated. So if you want to generate something, you can see 1.7. All those factors that you have generated, template will be available. Can you please show the code? This combination load can because this is a very powerful feature. A lot of things as we have mass modeler, automated load combination generator can enhance your quick modeling workflow. Say, for example, you are working with 10 primary load cases. It could be like, okay, you have 50 combinations. You do a lot of chances that you might be manually mistake all those defining the vectors, sign convention. And it is a bit consuming. Okay, anyway, let's perform the analysis. So while performing that, you can see any load analysis. Perform analysis is for linear static analysis, flow loads, and everything. Before I analyze, just want to show you what are the load cases that we have. We have simply defined the earthquake load, dead load, like these are the okay. We didn't define physical, so we have defined this flow load based on the ill theory. Okay. Question on flow load. there is something called, okay, let me close it. Sorry, this one, there's a joint. It's grayed out because there are few conditions that you need to satisfy. First of all, mainly what joint check is for ensuring that I have a strong column and weak beam, right? If there is any kind of earthquake event, and that system won't collapse, right? That is the main part criteria. So in those cases, mostly you want to do this ductility designing, and it will do all those joint checks. There are several other settings also. I have a separate video on this. Maybe I can send it across, but yes, it can do the joint check. Okay, now let's go to this detailed drawing for any one of them. This is one cross section for elevation. This is another one. You can see the richness of the design. And everything can be saved in the Autodesk. Sorry, what do you call it? .exe format, which can be opened in MicroStation or AutoCAD. And then design summary, the complete calculation if you want. Then if you want the detailed calculation, I'm not firing all of them. It will take a lot of time to generate those pages. Better I open one of them. Okay. And finally, you can see the failure diagnostic. If any of the members are failed, you can see reason would be shown. The clauses, if there is any, it will report you. Bar bending schedule is also very powerful features we have. You can do all the detailing and the drawing settings, like what are the things you want to include in this drawing and everything. Very detailed product for design and detailing. Even for the, believe me, this RCDC can also open the ETABS file before we acquired it, because it was used by ETABS user and STAD user also, because of this designing detail. Right now, I think ETABS are no longer supported. This is the bar bending schedules and this cutting length and all. Okay, so this is just a quick overview of RCDC, and similar way you can do same for the beam design. Okay, one thing just to add you, even if you're doing the beam design, even if you are modeling with the plate elements, if those beams are broken, you can still design them. Just sure. Right. Okay. So this is the one. Now let me go to steel design, okay? Quickly, because I have another half an hour, right?
Yes.
I'll quickly show you.
Break at 12 o'clock.
Okay, give me another half an hour.
Okay.
A big subject. How can I, cover all those things in this limited time?
Okay.
Actually, if I want to discuss some of the interesting, it will take a full day session. 1 full hour for concrete. Even 1 full hour is not enough, because RCDC will take another 4 hours. So anyway, it depends on the discussion depth we need. Okay, in steel is very interesting though. By the way, any one of you are partial moment release? Yes, you're using. You? Obviously. Partial moment release. So any axis, partial empty value, that is. Yeah. So part track normally longitudinal direction we will release. All full release or partial moment release? Full release. Or you don't use the partial moment release? I agree. Okay. Okay. I'll come to a few of the things. Let me discuss here. Let me open.
Actually, for steel structure, I have a question.
Yes, please.
Pre-approved connection.
Oh,
ACI pre-qualified.
Pre-qualified connection.
Yes. So how start incorporate that?
It's not STAT exactly, it's a RAM connection.
It's RAM connection.
RAM connection.
So it is there.
It is in RAM connection because STAT we can do the moment release and all. Like for shear connection, we are defining a full moment release, take it to the RAM connection. There we are doing the RAM connection design, where we also do the pre-qualified connection design. RAM connect, not in STAT. Okay. Okay. So let's see the steel structure. Steel is very interesting because a lot of things are there to consider, just like concrete also. Modeling one, not going to discuss a little more on modeling, but just to give you some reference here for the steel. How many of you are doing steel? Please raise the hand so that I can understand the voice of you. Steel, none of you. Sorry, one. How many of you are using the steel structure? Okay. Let me open one list then. Just I'm touching upon few of the important things. So your steel section could be of different types. Okay, it could be built up, it could be cold formed, it could be like any arbitrary shape. In 2020-24, we have replaced this section wizard with the shape editor. Are you aware of this, by the way? Okay. Tapered section. These are some of the arbitrary section. Now, let me go through a few of the things. So it could be like very simple hot roll section or any build-up section made with the hot roll. It could be a build-up from the plate elements like your web tapered, or maybe some of the arbitrary shape which are designed not in the like a hot roll steel. So all those things are possible to model and perform the analysis, but we need to understand a few of the things before we jump into the conclusion. Different ways to model the steel section. I'm just still in the steel sections, okay? So those who are into the other products have not comparing with other products. Every product has got its own unique merits and demerits. Just to let you know, in steel, as we mentioned, we have been here for a long time now. It has got enormous amount of options to model different shapes. For example, any arbitrary shape you have. For example, this one. It could be steel or it could be aluminum extrusion, anything, right? There is something called section wizard or shape editor by which you can model any kind of arbitrary shape. If it is in a DXF format, you can import it, you can assign it, and you can analyze it. Anyone of you using this arbitrary section, by the way? No need? Okay, just to let you know, anyway. And if you're into, into the factory shed, like where you have the web tapered section, you can model the web tapered section and we can also design them. Okay. Anyway, let me go to now the structure where we are. So this is a simple structure, but we are discussing few things here. Dead load by the group load. We have used a one-way flow load because steel roofing is directly sitting on the purlin. So there is no point in defining the two-way flow load. There is an option called the inclined flow and the one-way flow, and I have applied the group load. Okay. The group option is nothing. You need to define this floor panel by any group name. And while defining the floor load, the group name would be automatically visible. You need to just assign them. Okay. Anyway, live load we have. Wind load, we have a very dedicated feature to define the wind load. We have both the features.
the normal manual way of defining the wind load and also the codal approaches. Okay. So this is generated by the manual approaches where we can define the intensity versus height information. Or else if you want to select any code, then codal procedure would be used to generate the wind load. Okay, now one question is $1 million question, maybe. Okay. Yeah. I think those were used to that. But why I'm telling it's very important. That's the reason. For example, you can see there are a lot of options, right? Truss, tension only, compression only, cable, crank. By any chance, are you using this one, tension only? This thing, why I've chosen it, because these are some of the questions we come across quite frequently, and several users has got this doubts. So, for example, here I have few members. Like if I want to highlight it, assign with the tension on the specification. Do you assign it in your structure? Tension rod, tension only bracing, right? Yes. Good. Now, if you use the tension only bracing, what do you do in the combination? I mean to say that, for example, where we had seen like in the previous one, we used the load combination. Do you use the load combination?
For tension only, if we are using load combination for that, then it will not. The result is not
Okay.
come out something like that. So we need to iterate something like that.
Yeah, we're very close to that. For example, here we have loads, right? Some primary load cases. I can also use the combination, right? Can I use this combination? Not what the combination means. I have to combine, right? To get the combined effect. For example, 1.5 dead plus 1.5 live. Can I use the direct combination? Yes, he is close to that, but the point is, if there is any tension only, or compression only, or P delta, we can't use the load combination directly. The reason being, these are the nonlinear state. Tension only, we have to iterate to convert this problem, but if the model has got the P delta analysis, direct analysis, tension only member, compression only member, these are the nonlinear analysis. And if we do the load combinations, what it does, it will simply pick up the result from the primary load cases and algebraically sum them up. You get my point? Okay, let me go here. This is important because in some cases, for example, you are using the tension only, or maybe the mat foundation. I have seen a lot of users are using the combination, normal combination, come back to us like, okay, they are getting very misleading result. What to do, I'll come that later on. Say, for example, if I have this guy here, and you have applied a load P1, and the displacement may be P1, and in second instance, P2, and displacement is D2. Okay. Now, if I want to see the combined effect of P1 plus P2, what would be the displacement of this? Pardon? Means in our intuition, it says that it should be like D1 plus D2, right? It's our intuition. If it is only possible if we are assuming that the system behaves linearly. Okay. Now, if the system behaves linearly, that means first that needn't have to solve for this load vector.
it can simply pick up this and add them together. If there is any factor like 1.5, it will multiply with 1.5. So it needn't have to separately solve this. That's the reason it called the linear. Linear means superimposition is possible. Okay, but if the system behaves non-linearly, okay, if the system behaves non-linearly, then it's not necessarily this would be same, only this one. In that case, you need to solve for this load vector and see what is the actual displacement. So if your structure has got something like this, like tension only bracings, or maybe some supports we have, which is having compression only support, or compression only member, anything with tension only or compression only or P delta, or maybe direct analysis. These are non-linear state. Okay. And because of its non-linearity, you can't use this load combination as I mentioned. You're not allowed to use the algebraic summation. Superimposition is not allowed. You need to solve for the actual load vector, means combined vector. So in this case, instead of you directly using the load combination, there is a feature called, I think most of you might have come across before. I don't want to add it one more here. Let's see if I can. Repeat load. As he mentioned something iterated, I think he tried to mention this one, repeat load. The repeat load is similar to this load combination. There also you can pull the basic load cases, define its factor, but it will create a new load case. That's the reason all the load combined effect that you can see here, I have already created them. These are all shown by small letter L rather than C. That means this is a basically load case itself. And within that, you can see the combined effect are already included, wherever if it is required. So if you use the repeat load case, then a new load vector will be created and it will be solved. So even if it is a non-linear, you'll get the exact result. So let me show you a very interesting thing. If I have this, let me see if I can show this. Any question on this, by the way? Now you should consider this because tension only, compression only, you have to model it at certain point of time, be it member or the soil support. And soil has compression only property, right? So it is again non-linear. Now in a structure, there will be wind load plus gravity load. If you use the normal combination option, your structure might give you a very misleading result. Let's see this one. This is one of the example I have taken. So here you can see this is the lateral load, gravity load. Okay. And what is the support condition I have defined? Plate mat. Compression only, spin. Okay. Now again, it is a non-linear state. Now if I use the normal combination, say for example, if I use the normal combination, I have a terrible bad throat. So you can see the normal combination. I am having the displacement of something infinitely high, e to the power 12. The reason being, there is nothing to stabilize because this is non-linear state. As for the first load case, earthquake load, it is like load without any gravity, okay, without any gravity, for example, load without any gravity, and I have a compression only spring, means something which can only take the compression and can't resist any kind of uplift, okay. Say, for example, a very light, maybe styrofoam like thing, if you apply the wind, it will topple like this, right? Because there is nothing to stabilize it, no gravity load. It has got a gravity load, but imagine there is no gravity load, it will topple like this, right? That is the reason for the first load case, you are getting unexpectedly high displacement. It's fine. We are not working with primary load case. We are working with the combined effect. For the gravity load, it's fine. But whenever we are using the combined effect, still we are getting so much of high displacement, which should not happen. The reason being, it is a misleading result because it algebraically is adding both the result. Okay, now let's see how to overcome this. We have used this one, fourth one, as a repeat load case, where we have used the same first two load cases. We have pulled together whatever the factors you want to include, and we have performed this analysis. Now, in the repeat load case, you can see that we are getting a very decent result because it is actually solving the combined effect by creating a new load vector rather than blindly taking those primary load responses and algebraically solving them. So remember this, if you design this, maybe you are getting a lot of misleading result for this. Anyway. Let's see this one. Okay, so we have got so many things applied. Now, these all are generated through the automatic load combination generator, okay, by this one. Okay, here you can see ACI, ASC, ASC, whatever code we have, we can do. And please note that we have the load envelope. I don't know if you are using it or not. There is a very good feature in STAD, even if you are in the industrial structure, is very required. That within the same parameter block, you can ask for both the serviceability and the strength limit state check. What you need to do, you need to define this envelope definition. These are the load cases for the strength limit state. These are the load combination for the serviceability limit state. Okay, because in the serviceability limit state, you are not factoring, right, mostly. So you can ask the program to include this one. And once you're done it, program would automatically check both the state. Now I have performed the analysis. Time is limited, or else I could have explained a little bit more on this partial moment, please. If you have any question on partial moment, please, you may ask. Okay, now let's perform the analysis. So steel designing in progress. Okay. Now, in the steel design, you can see something like effective length factor, which we have included in the 2023 versions. Anyone can say that what it is for, or anyone used this before? Effective length factor. If you're in the steel at certain point of time, very sure you need this. LY, LZ, or you can say factor is KY, KZ. So what is the factor you take? Default member length, or that is the KY value of 1? 1? Or you calculate?
We calculate, mean, if, let's say like an actor, you also have for lane. So distance between for lane, then we could.
Yes. Okay, but
something like that.
exactly. But what if I
if you want to find this effective length factor for this one.
You calculate.
Yeah,
Manually.
yes, obviously calculate. How you calculate?
Considering this the beam
Hmm.
on top and
Yes, yes.
below, and then the steepness of the
Yes, exactly.
of the
So basically alignment chart is there, right? So we have to go through this alignment chart and calculate it. The calculation is a bit complex. The reason being, let me show this one if I have this.
but practically we will use 1.5 something like that
Yes, yes,
because it is difficult to use a different number.
exactly. That's the reason we have this. Let me show you. This one.
Yeah.
This is the alignment chart. We have different conditions, sway, non-sway condition, and as you rightly mentioned, like the top beam, lateral, all stiffness we have to consider, and relative stiffness we need to consider and find this. Now, very tedious process, and sometimes for all the other beams or members we have to calculate. So there are two different solutions here. Do you know the best solution where we needn't have to calculate at all? Anyone aware of this? Especially for the building. I don't know about any other non-building structure, but normal for even for the pipe deck also you can use it. You needn't have to calculate at all. Just keep the default member length k equal to 1. Have you come across the direct analysis? Yeah. If you are doing this,
It's your structure if the height or regularity is not meet the code. Or yeah, the height is more and the structure itself categorized as irregular, then we can run with that. But I don't know. I haven't noticed that we can use how to define the k value.
Okay. See, direct analysis is a very powerful analysis feature defined by the AISC code. Previously in AISC 365, they have encouraged means what? They are more into the ELM method, this effective length factor method, where you have to calculate the K factor. And direct analysis method was only defined in the appendix. Later on, AISC brought this direct analysis, this entire chapter in chapter C. There is the designing in the stability. That means what? AISC now emphasizes or give the stress more to use the direct analysis method. It's a very interesting method where during the analysis phase itself, all the nonlinear effect, for example, the second order effect due to the imperfection, P delta, these are all captured. And that is the reason AISC states that if you do the direct analysis, then you need to keep the K factor of 1. Clearly it has mentioned AISC. Okay. So you didn't have to calculate the K factor at all if you're doing the direct analysis method. And that is the reason even if you go to the after 2010 or 16 onwards, almost every other code are who are using reference AISC code strongly recommends on direct analysis. But still it is optional to the user if they want to use it or not. Just to give you some idea, like this direct analysis method is already there in StatPro. If you want to include, you may choose this. For example, from here, there is something called direct analysis definition. Okay, it's a very big chapter. If you want discussion, please let me know. We can have a separate discussion on this. But yes, we have got this. If you do this, then you needn't have to calculate the K factor. You can keep the K factor of 1. But if you want to ignore, it's up to you. So even if you ignore, still we have recently added this one, effective length calculator. If you click on this, you can select the member from the list on the group. And if you want to quickly generate it, it will calculate the K factor for you. So you needn't have to calculate all of this manually following this nomogram. It has got its inbuilt calculator because a lot of users are requesting us to include this calculation. Okay. Okay, one more thing we have. So can you give me 5 minutes just to show you this optimization one? Okay, because this is very important. So let me go to first. It's very interesting as well. Okay. Now just see here. Let's do a little bit of quick check here. We're designing this, okay? Just stay a little bit of attention here. Last part of this, and after that, quickly show the RAM connection. Okay. Now let's see here. Go to this post processing. Fine. Now let's go to utilization ratio table. What can you see here? 0.81, 0.66, 0.7, 0.71. And there is also something like 1.37. What does that mean? It also shows by the color code. It is red. I have only designed for this parlance, okay? So one of them is failed and others are passed. Obviously, these are passed, means the ratio is less than unity. But I still have the scope to improve its section size. For example, 0.635. I can increase its section, right? It could be a little bit more so that the ratio can be near to 0.9 or 0.8. And for this, I need to increase the section size because it's failed. Okay. Now, please be noted that in design, we normally use the check code, which is just to check its adequacy, like demand versus capacity. But there are a lot of other things by which you can use the program to optimize. And very famous one is the select parameter. Select optimize, select parameter does the same thing, but select optimize it's one step ahead. So normally you do this select command. Select command will, what it will do, it will pick the most suitable section for you, which is satisfying the codal clauses. Okay, if it is failing, then it will select the next heavier section till it gets passed. If it is passing, but the design is very conservative, like heavy section, it will try to reduce this section until it is passed, but within the ratio less than 1. Okay, now let's see what we can do by using the select command. So I have already included this in this example. So before I coming that I have created this model just to show you. So for example, instead of check code command, I am using the select command. Now, if I run the model, okay. Now, please see here, if I run the model this time, and if I show you this same utilization ratio table, you can see here, all of them are passed, but This is my actual section 1835, and it has picked this one. It was 1835, it has picked this one, and for this one, it has picked a different section. That means what? If I double click on this, this is my actual section 18 by 35, and this is the design section. It's the most optimum section it has picked, 12 by 26. For example, this one, it is my actual section 18 by 35, and this is the optimum section it has picked. Now, if you see this, all those sections that it has picked are very different. 8 by 24, then 8 by 24, it's fine. If I go this one, it is like 8 by 31, okay? So every section it has picked is a different sizes, different depth. So practically, can you lay this reinforce, say in the sections in that part in which is having different depth? We can't do, we have to maintain some uniformity, right? Yes. Because it has optimized it for me, that doesn't mean that we can practically use them. We have to maintain some uniformity. So that is the reason we have something called group command here. Same thing, we are almost done. Just another 10 minutes, give me. This is group command. What group command would do, it will try to find the most optimum of all the optimized section that it has picked. And it will use it for all the other sections. Okay. So this time we have already done this. And here we are invoking this group command, which I have already placed before. So this time it is a little bit of iterating, means finding a right section, again checking that whether it is fitting there or not. Starting the design. Yes, it is done. Let's see this time what it does. So all the, sorry. Let's see, the design ratio is fine. All of them less than 1. If I double click on any of the section, let's see. This is the original section. Design section is W12 by 26. This is again W12 by 26. This is again W12 by 26. Anything randomly if I choose. W12 by 26. So all of them are designed with the same sections, following the different design rules. Now you can put it, but again, as I mentioned before in the concrete part, is there something we need to do more after this? Because we have made a lot of changes in the section, right? We have to reanalyze it. So the stiffness is changed. So the best way is, after you have done this first set of design command, you just invoke a perform analysis command just to reanalyze it. Just one step you need to do. And you define another design parameter block. This time you needn't have to use the select parameter, just with the normal design ratios and other parameters, and conclude it by the check code parameter. Just to see the final design ratio with the updated demand, because we have changed the stiffness, and with that changed stiffness, we have reanalyzed, right? Okay, let's read on the model again. Hold on. Okay, now from here, if I again go back to the post-processing result, this time I can see two set of design parameter block, first and second. Always see the second one, okay? Final design parameter that we have. And all of them will be passed, and whatever the design ratio you are getting, it's fine, means this is the most optimum possible. So this is the way you can optimize your steel structure. And if you want to see the final design report, you can go to this output file. And for example, 408, you can see the complete calculation, serviceability, compression, slenderness check, tension, yielding, rupture, flexural buckling, flexural torsional buckling, and everything. As I mentioned, for steel, that honestly speaking, it does a lot of things. And also the deflection check, it will do it for you, that whether it's satisfying the serviceability limit state or not. You can see the deflection check is also done, actual deflection and the allowable deflection. So once you're done with this, you can go to the RAM connection from here. And this is the connection design. And from there on, you can go to the RAM connection. See, I am just showing you a few of the important things. This structure I could have taken for one day. A lot of nitty-gritties I could have discussed, but you can understand a lot of things we have to discuss. Let's open it. By the way, any one of you have expressed? Any one of you have come across the instability warning before? Yes. Yes, it's very common, right? If you're in the steel structure, obviously. So how you are overcoming that?
We see what is the like the door number or bin number specified in the warning note, and check whether if we can understand what is the problem, then we can repass like adding. I mean, normally it is related with release or put like a fixed bar, and we make some mistake in putting checklist check mark in some direction, or we forget to put some check, so it's become instability.
Yes, you're I'm coming to that. You're almost there. Somehow it's got clear. How to remove this? Every other time, yeah, it's getting very irritation. Just one more minute. Hold on. Because this is instability is, as he has mentioned, if you are in this, what do you call it? For steel structure, it's quite common. Let's see if I have something like. So many applications are going somehow. Anyway, somehow I could recall it. So this is where you can do the steel connection design. After you go to the connection design, I'm just quickly showing few of them. Let me delete one or two. So this is the interface you can, and for the steel connection design. So this is where you can integrate with the RAM connection. But please note that RAM connection comes under the structural work suite. And if you use the structural work suite, you will get the entire workflow. So this is, for example, we have a lot of different options: basic, smart, gusseted plate, and so many options. Basic connections are simply like your check code command. It will check the demand versus capacity ratio. That's all. And the select, just like a select command where it is optimizing, it's very similar to the smart connection. So here you have different design codes you can choose from, and you have different templates here, right? It's template based designing. You can choose the templates from here. If the connection seems to be qualified, you can get them here. I think which one I have designed. I think this one. This one, let's see. Yeah, this one. So this is your connection. That is, I think, for the welded one. Let me show the another one. Maybe this guy. All the loads and everything are joint forces are everything imported from StatPro. You can make the changes if you want. And if 1 row or 3 row doesn't matter. If it is a bolted, welded, you can and immediately you can see that the design ratio is changed. And you can see the DXF file here. Okay. And you can export this DXF file in the drawing format. And if a lot of things you can play around, like if you want to include the stiffener, you can add all those stiffener position and everything. And after you are done with this, you can get the result, detailed result. You can see the result. And if there is anything wrong in calculation, it will immediately show you. And this color code is very important. Yellow means by strength it is passing, but some of the geometric criteria it's not fulfilling as per the code. And if you need more calculation, you go to this alpha. If you click on this, it will generate a very elaborative calculations and details. Okay. So this is the RAM connection where you can design different connection directly from STAT. Now the good part is, apart from the standard connection, it can also do the base plate connection design. And as it's directly integrated with STAT, for example, there are hundreds of connections. You can fire all those connections together. There is a tool by which you can fire all those connections together. For example, all beam column joints. It will select all the joints which are qualified as a beam column or BCF joint, and it will design it for you. Similar to that, we have something called this smart connection. Okay. If you use this smart connection, it will not only select the right template, but also optimize the plate thickness, welding thickness, and all. So for example, I think this one was, yeah, smart connection. I can see this optimize option is there. So it's already optimized, and accordingly, you can see the best ratio possible. Okay, now finally, there's a very important thing. Let me show this one maybe, because this is the entire workflow I'm showing. Let me close this guy first. So you can see steel auto drafter. Anyone of you use this? The steel auto drafter. So it comes with your package. Steel auto drafter is a drafting software. So the moment you click on this, it's a very small, very compact. It's not that complex software, but it's a very helpful. It will generate an interface like this. For example, I want to generate a drafting drawing out of this. Just select the drawing direction. Say, for example, I want to see like this from Z direction, full section, partial section, 2D section, the scale, everything you can control. And you can generate the drawing. And this drawing is very nice, means grid lines, everything, and you can save this one in the DXF format, which can be opened in the AutoCAD. Now, if you think that no, my drawing doesn't look good, I need to add a bit more information, that's fine. There is a drawing style manager you can control. And also on top of that, you can also save it in the DXF file, and in AutoCAD, you may add a little bit more information if you want. But the most of the important things, these are all generated. Okay.
Can we import the drawing format from AutoCAD and insert to?
Oh, drawing format from AutoCAD insert to the still AutoDrafter, you mean?
Yes.
No, it's not for importing any drawing format here, but you can export it.
Okay.
If you want the drawing to be imported, you need to import it in directly in STAD. Means if you want to import, there's something called DXF file in STAD, where in STAD you can import any DXF file.
No, I mean just the drawing format. So
No. Okay, you just want to
Yeah.
merge them, right? So we don't. I can take it as a request, maybe. I can put it to a development team. But yes, here you can generate this one, and also you can get the material takeoff if you have done the steel design with the material takeoff information for the complete detailing of this. So after everything, there is something called foundation design. Within this UI, you can fire this foundation design and launch this. So there we have a lot of different options. Now I'm not going into all of them, but just to show you this isolated footing, we can design the mat footing, combined footing, everything. Now here we already have this isolated footing job created. All the support reaction, everything will be imported from StatPro. Okay. Now here you can define the concrete property like unit weight, its spacing, minimum, maximum reinforcement, everything. Soil information like SBC of soil, any factor you want to add, depth of water table, height, everything. Putting geometry, it can calculate the geometry, or you can set the geometry and ask the program to check. Okay, for example, I'm doing the calculate geometry. A lot of other checks you can do, sliding, overturning checks, everything you can do. But right now, I'm just firing the design. Now it will do a very rigorous design. For example, isolated footing. If you're in the, for example, any industrial structure or maybe tower, those footings might experience a little bit of uplift, maybe. So not the overall uplift. For example, some of the corner portion loses the touch with the soil. Okay, we call it the contact loss. So if it happens that some of the portion has the contact loss, that means we are having the lesser number of area which is in contact with the soil. For example, this is actual top view, okay, and due to some biaxial movement and all interactive action, this portion has lost the contact with the soil. This portion. Now we are left up to this portion, effective portion, which is still in the contact with the soil. So the pressure will be redistributed to this new effective area, right? We have to reiterate. So that is the reason if there is a contact loss, we can reiterate in our footing design. That is the reason you can see so many iterations. It is in progress and we have so many load cases. So it will design it. If it is done, then I'll show you. But that is what we can have entire thing in this workflow. And if you're in the concrete, please be noted that we can also do the slab design in WAM concept after this. If you have any question, because so many solutions in STAD itself is such a big with steel concrete. Almost I've touched upon 2 different solutions that we have. So just let me know if you have anything specific.
So, may I ask in start foundation advance? So in contact area pressure, in ultimate work case, when we will use the percent.
Which one this is? It is? Okay, also please be noted that we have another set foundation advanced 2023. It is having completely new interface. In next week, please stay tuned. We are launching this one where isolated footing is also included here. This is completely new interface, okay? Oh, yes. Okay. Right now you use this one. This is the existing older one, but in the future this will be phased out and another will be used. So the newest stat foundation is a little bit more advanced, where you can get all those detailing. In the existing one, you might be having something like for mat foundation, you don't get any detailing, but in the newer version, you'll get the detailing of everything. Mat foundation and then pile cap, every detailing you will get. Yes.
Yes, and in Stock Foundation 2024 release note, I see that
2024 is released.
The release notes.
Release notes.
Yes,
Yeah.
not the installer. And
Let's see.
we can choose the method of analysis from rigid and analysis.
Right.
Yes,
right.
It's not available in version 9.
Earlier version, no. Means for the isolated footing, you mean?
Yes.
No. That's the reason. In 2024, you will get this option.
Yes.
You want to take it as a rigid or flexible. The reason being, we are given the choice to the user. A lot of users coming back like, okay, if it is isolated, generally if isolated is smaller one. Really, for the simplicity of calculation, we consider that it made this case, right? But in some cases, we notice user come up with dimensions. They are expecting some internal bending. So like flexible foundation. So we generally advise them, okay, go to the mat foundation job and model with the plate elements. That is the reason in the newest version, we will give the option that you can directly choose the option rigid or mat directly in the isolated foundation module. Program will automatically calculate the mat foundation if you have selected the flexible. Okay, any question?
So, Pak, I want to ask
Yes,
in
please.
maybe general question, yeah. So, what is the newest, the most advanced of the
H1.
Stat Pro?
Stat Pro is
Stat Pro,
2024.
Yeah, 24 from before.
2024.
Yeah, what is the most advanced between the other software? Maybe like subdivision or
Okay. Comparing with other
yes,
software,
yeah.
I can't compare with other software because it's beyond my policy to compare with other software. But
Okay.
what I can do, I can tell that what is the best part in the other software in Stat
Yes.
Pro. Okay. First of all, the best part is having the integration, because the integration is all the softwares that we have. The very beginning I have shown you. Okay, let me show you before I wind up. A very interesting thing. Let me show you. It's Edina. Okay, now.
Yeah.
This is something, one of the most advanced thing. It's called Edina integration. Do you know this, Edina? Okay. Give you some peek on this. Edina is recently not 2 or 3 years back, we have procured it. It was developed by the most stalwart in the finite element industry. He has his own book, Yarchan Bathe. He is now our Bentley consultant because we have procured it. He developed in MIT back in 1986. Anything that you can say that, okay, Stat can't do that, Stat can't do this. Yes, every software has got its own yardstick. But with this Edina solver, the options are limitless. Why I'm telling you so? Let's see this. So you can simulate anything, any kind of structure or any kind of situation, be it structured, thermal, CFD, electromagnetism, doesn't matter. So for example, crash simulation. Instead also we can do buckling analysis, but it has got some advanced capabilities. This is the one, for example, if there is a fatigue, you want to simulate a cyclic seismic load you want to simulate, we can model it and you can see that the permanent plastic deformation develop, inelastic deformation. You can simulate the same thing in Edina. Crash buckling.
This will be separate package.
Yeah, separate package, but it has got the integration with that. Good news, maybe, I'm not sure. There is a talk like it is supposed to be included in the near future within this year only. I can't promise the date because management is still working on this worksheet. Worksheet, yeah. Once it is available.
So it is higher than advanced package.
Higher means what? Pricing?
Yeah, pricing.
Pricing, I can't say pricing, they can say.
I will show you one. Nice.
See, it has not been yet officially included, but
There's
it
a
is,
plan.
yeah, plan. Yeah, there's a plan. So just keep you updated of this, and it is very shortly. Why it is so? Because, for example, anything, just imagine like retaining, a tank with the water, it is moving and sloshing effect is there. The hydrodynamic effects that we can't do, but there is some indirect way like convective, impulsive. We have to divide two different static component and we can do. In Edina, we can do it by solving it. So anything that we can't do is that we can use the Edina solver and perform the analysis instead. Now, for example, this is the structure instead. You can see we have done it in the physical modeler. I'm just quickly going it because we just want to. If you go to physical modeler and export, you can see small little tab is there, Edina. You can also see there. You can take it to the Edina. So in the Edina, we have sky is limitless there. So this is the market leader in FE analysis. It's only competed, we can say, I should not name any other software, ANSYS or Abacus or other, but it's a university product. Remember this. So it's a developed in MIT for specifically for the research purpose. Sorry. And the good news is that would be using its solver in the recent time. So that's the beauty here. And another powerful thing. Okay, and let me tell you, did you come across this one, advanced flow load? Did I show you? Have you come across this? Okay, let me tell you, this is available since 2020-23 onwards. I know that many of you are not using it. It is already there in the load case, enclosed floor load. For example, you have this type of floor panel, and you have two cantilever beams, which is not having any terminal support. Should you apply floor load on this in the normal stat? It won't allow you because you don't have well-defined boundary. But right now in V2023, we could do it just like this if it is. So we have been developing it leaps and bounds in the recent times. I'll show a very interesting example, another one. In the pre-V2023, you would have some garbage flow load distribution like this. If there is any kind of panel which is not subdivided into two different parts, but right now we can do it.
Is it using Edina?
No, it's a normal one. Edina one I have shown it in V2023, the latest one. Okay. Okay, now let me show you another one with Edina. because I have done a recent kind of seminar on this, on solar structure. And some of the things we may think that, okay, solar structure looks very simple, but we have noticed that in few cases, these are very complex. So many files are opened. So it's my structure. Just give me one moment. I think it's to show a very interesting thing. Those few. Okay, the point is let it open. If it is opening, then it's fine. With Edina, we can do a lot of advanced analysis, which you think that it's not possible. Another is you might have seen that in your roofing system, whenever there is a flow of wind, vortex shedding and other complex aerodynamic effect generates, right? For example, you are building any steel structure, for example, pole, wind dynamic effect happens, right? You can simulate this entire CFD system in Edina. And finally, we have RAM structural system, which is also part of this structural worksheet, but it is not to be linked with STAT because it's meant entirely for the tall building, just like your ETABS. Okay, STAT is there, but it is meant for the tall building. Let me quickly give you some abilities because it's a completely different software. If you're into the tall building, you can use it. The reason being here, you can model directly by floor system. Just define the floor geometry, define the floor height, complete physical model will be quickly generated. And it has got different types of ready floor diagram you can directly define. Rigid, composite. Composite deck, if any one of you are using for your structure, you can use RAM structure system. Very good implementation we have. Composite deck. Buckling restraint, brace frame for seismic resistance structure. We do have different kinds of library. Buckling restraint, brace frame with the core brace. We do have something like this, which will yield internally, where it will not like a conventional bracing where you can expect some unpredicted buckling. And it has got a construction stage analysis. So that every floor is constructed at different time, right? So both the geometric and time dependent effects are not same, like creep, shrinkage for the top floor and the first floor, right? So that's the reason we need to evaluate the construction sequence and its impact on your structure. Let's see this. If you don't do that, you might end up getting some column shortening effect, and this might impact your non-structural element failure. One-click wind load generator. It's mostly STAT, but if you're into the building, tall building, it is much more advanced in terms of performing the analysis and quick modeling. Delta analysis along with the response spectrum. Also, we can do it in STAT. Here also we are doing same bits analysis. We can do it there. Wind tunnel test result, if you have, you can feed. So in short, it is meant for the tall building. You can feed all those simulations here. And it has got some interactive physical model that you can see. It is somewhere in Middle East. And that thing, so heavy model, was modeled in the system. Okay, anything specific I have so many things with me, but I need to know what exactly you would have to understand. Sure. Anything else?
Okay, I had one question regarding Slate or Slack.
Slab.
Like, how do we know that the working shear is already below the concrete shear capacity or slack shear concrete capacity?
Okay, very good question. See, this is one of the questions we also used to face in our technical support days. For example,
Because in start output, it is come out with, come out as a stress.
yes,
Not as a
good. Yeah, true enough. I'm going to show this. Say, for example, here's the column. Column is landing here, and you want to see that, okay, in this region,
Yes.
doing punching, whether my total force is passing the capacity or not, right?
Yes.
And you are very true that it doesn't give you the force. What it gives is stress. Now, if I tell you, there is a way to do that. Instead, there is something called SQX and SQY. This SQX and SQY are out of plane shear. Okay, so if I take a small element like this, the shear action for this is out of plane, and this is denoted by SQX and SQY. Now, this is the local axis orientation. This is the X, and this is this is the Y. So this would be like SQX, and this would be like SQY, right? So what you can do is, first of all, you find this SQX and SQY value. Now, I understand that these would be meshed, right? Small element will be meshed. I have a separate calculation on this. I have sent it to one of the users. So every element has got its own SQX and SQY multiplied with this area. Multiply this with area, multiply this with area. For entire thing, what will get? Total force. Okay, we'll get a total force, and that total force you can compare with the concrete capacity. The concrete capacity also, if it is shown by some stress value, you also multiply with this cross-sectional force and just compare whether it's exceeding or not. This is the common way we are doing. And these things actually you can automate it through OpenStack. If you write the program, like, okay, I want to calculate the stress value for this zone, you can program it OpenStack. Okay, say for example, generally what happens, I think it is for some code, it is d/2 distance, in some code Euro code, I forgot this, some distance depending on the thickness, they want to check it for punching shear. You can write the code and you can program or identify the element and its stress, multiply this section area and give you the complete result. Then we compare with yes, exactly. Okay, thank you. Any question?
Pak, gimana Pak? Silakan. Ada pertanyaan?
Yeah, please.
Ayo silakan. Ibu,
Anything,
Bapak.
please don't be shy. I know that many of you are new stat user, but if I go with each and every new step, then a lot of important thing will be missed. And if I go too advanced, then a lot of basic thing would be missed. So it's very difficult to match with everyone's pace.
Sorry,
Yes.
start foundation again. So the development of start foundation advanced from version 9 to 24 onwards will bring the mode of version 9 to the newest version. I mean the general mode
Oh,
Plan
more.
foundation and toolkit.
No, in the 2020-24, we don't have anything like toolkit or plan foundation. Only the general foundation would be there. Plan foundation would be added in the later phases, but till now it would be there in our existing UI. That is the Tab 9 or what you call it. In this UI only it will be. So if it is the building mode, then you can import this, but not for the client. Okay, now you can see here, this is a what is the wind effect on the solar panel, right? Now, in the normal scenario, what we will do? Wind will hit and we'll see that, okay, the forces is good or not. But what if my solar panel is fluttering like this and going like this, and all the forces are cascading into the next set of panels. See? So you can't do it normally instead because you don't know the wind flow pattern. Because what we assume instead, wind load is acting in a laminar way, right? But once it goes all over the different surfaces, it gets into very violent and turbulent, and a lot of effect like vortex shedding, then aeroelastic effect. These effects are mixing. So how to simulate this? For example, this one also. For example, this. Okay, this is aeroelastic effect. Okay, so this is not a resonance. Okay, this is aeroelastic effect. Wind is affecting this vibration, and this mode is again affecting the direction of wind flow. And at any point of time, this may fail. Now, I'm not going to, obviously, we are not expecting to design an aircraft, but this phenomena is very important for your structure also. For example, signboard, billboard, these are also behaving in a such a way, or some electric pole. This one may be. This is in a famous Tacoma Bridge. It was failed because of this aeroelastic. Now, these are very complex analysis. Okay. Now, in EDINA, we do have. In fact, the code, I'm coming to that. Code says that if your, I'm taking it from Indian code, if your structure, which is subjected to the wind load, if there is a phenomena which is too complex to justify the generalization of the wind forces produced by the interference, which can only be ascertained by detailed wind tunnel or the CFD study, CFD analysis. Code specifically says that. This is the EDINA for you. You can see, you can simulate the wind flow, even if it is not laminar. So you have seen this turbulence index and all this. And these are some advanced things on CFD, but yes, we did one webinar on this. We have nicely tried to simulate some fluid structure interaction. Okay, so anything else? Yes, madam, any question? I think she want to ask, but could not communicate with me. Anything? In your own language, you can ask her. She can interpret. So, did you find STAT useful or helpful in using StatPro? As a new user, is it easy or it is difficult? Difficult. Okay. See, I know that a lot of things we can't cover. After every license that you procure, right, Virtuosity, we are getting some free trainings, Virtuosity keys, and we are delivering those trainings. One-on-one training. Considering that, okay, you are completely new, we will start with the basic things. If it is intermediate advanced, we'll start with the advanced things, right? These are the free training we are offering with our every, license that we can explain.
Silakan Bapak Ibu. Bisa dipahami nih Bapak Ibu ya. Semoga ya. Yang penting kan penjelasan jelas ya. Cuma masalah linguis mungkin ya.
Okay,
Tapi
one more thing, eventually last thing, let me show this if I have to. This is important, I think. Like, wait, so many slides open. Let's see. Yes. This is the one. So we have so many things, but you could see that most of the things are covered under this worksheet.
Saya masih nanya sih Tom, nanti saya lari.
Okay, so something else. Okay, if you want to see the type of industry that we are using, let me going to just concluding. Starting for the solar industry, residential and industry building, steel structure. What are the features used there? Lead analysis, advanced concrete analysis, tension only, compression only, steel optimization, dynamic analysis, building structure with the plate elements. Okay, and you have this building structure, you can see with the plate elements. This is a metro station building, underground metro station building, embedded inside your station, depth underground. This is for Delhi Metro. I visited their office in New Delhi back in 2019. Huge structure. It looks simple. When it opens, it takes several minutes to open it. So they have to model all the soil structure interaction, compression on its springs, then hydrostatic load, everything. Industrial structure. These are the user model, okay? This is not that I have created. Silo and bunker, heavy footing model with the solid element. Liquid and water retaining structures. These are the liquid and water retaining structures. Transportation. Flyover plate girder. Box girder. Dam. Wind turbine foundation. This is model with the plate elements. Okay. So you could see like not a single type of structure we are sticking into. Options are limitless, just you need to know how to play around. For this, you might need some training, maybe. Those who are expert, that's fine. Those who are new, just to let you know that after you procure the product, we will deliver you the complimentary training for this. Depending on your requirement. If you're new, you're in the building industry, we'll understand your requirement and prepare the course for you. So no need to worry like, okay, you have procured it and we are just running away. It's not like that. We are there for supporting you, train you, everything. Foot and over bridge. This is a bridge in Philippines. The user has sent me just to evaluate existing bridge. They have sent, you can see some of those information they have sent. And this you can see the bridge, and this is in the stat model. The cable state bridge model with the advanced cable analysis. This is very interesting if you are in the building industry, if you are modeling the facade. And this is the Buddha statue, which is modeled somewhere in India with the plate elements. And that things was modeled by the finite element. Okay. Okay, friends. Questions they have. We are till this.
Bapak Ibu nanti kalau mau ikut yang sesi kedua, kalau absen lagi ya, visi ya, absen kedua visi lagi. Biar nanti kita ada kata tabrakan dengan yang berikutnya. Jadi silahkan kalau bisa absen lagi Pak ya. Kan dua kolom tuh, ada 2 kolom.
Makanya beda.
Gimana Pak?
Makanya beda.
Nanti mix aja Pak. Yang baru mix ada, yang dari pagi tinggal lanjut ke kedua. Kalau misalnya mau ikut silakan. Pertanyaan lagi sampai sini.
Yes. Yes, madam. Any question? I'm asking because some of you might be shy, so that's what I'm asking.
Iya.
No need to be technical question. Anything like training or any other thing you can ask. No need to have something.
Jadi Pak udah maksimal Pak penggunaan start tool di KPT, udah maksimal full ya. Semua
Tergantung project Pak. Kalau project ini kita
full.
nggak terus. Kita kalau ada project ya.
Iya, ya artinya penggunaan interface udah maksimal semua ya. Pure. Oh. Jadi kira-kira dari informasi dari Pak Biswatos gimana Pak? Yang
So we are not using like the RAM connection we haven't foundation right now. We are shifting from different foundation to this start foundation, and we do like internal checking prior to use it.
Please stay tuned for this step. We are coming up with a lot of things in the latest one, the 2024.
So do you still open the start foundation and first program?
That foundation, what?
Start foundation program. You still operate? I wanna ask.
Which one? 2024?
No, previous one.
A previous one.
In cover and soil parameter. So yes, there is the maximum percentage of contact.
Yes.
In ultimate loads.
Yes.
When will be used it?
Yes. Not maximum, it is minimum.
Oh, sorry, the minimum.
Yes, that's the what that I have mentioned you. Say for example, you have a footing like this, and some of the thing due to this overturning effect, this loses the contact. Now, in some cases, a lot of users can compromise with this contact loss. They may be okay, 2% contact loss, I'm okay with that. Okay, because you can't say that can be 100% that should be in contact. In some cases, there will be slightest contact loss. So you can ask the program that, okay, I can allow 5% contact loss. Beyond that, if it does, please throw an error message that the design is failed. That percentage you can define that this limit you can allow.
So the difference between surface load and ultimate loads only the load combination.
The difference between what?
Surface load.
Yes.
Only load combination.
Yes, exactly. One is for designing and one is for just sizing. Okay, now this 2024's that foundation, let me show this. This is a new interface. Before I go to the 2024, let me show you 2023. So just to give you some updates, when you install it, both of them would be installed on your machine. It's not like that here we are designing the superstructure, but our plan is in future superstructure also design the same platform. It would be great one. So yes, so now you can import everything from stat just like you do it in normal stat foundation advanced. And then you can perform the analysis statement. In 2023, we didn't have the isolated footing. 2024, we have been. Yeah. And the best part here is it's rendering, detailing, analysis options. It's a different level. Even if you have different orientation of mat, you can design, not only design but optimize. We didn't have any optimization routine for mat in the previous version, but here we can optimize the mat foundation also, steel and all. Live reporting, this one, design optimization that I mean.
Can we create foundation from scratch?
Yes.
In 2023?
Yeah. Two options are there. Not two, three options. You can import the foundation from 9. You can create it from scratch here. You can import it from stat.
I tried using this version 2023, but I cannot create the pedestal.
No, we do have this pedestal option.
In release note ISO, the pedestal can only be edited, not created.
Yeah, edit means if you have imported it from
Yes.
stat. So yeah.
But
it,
we cannot.
No, in the recent version 2024, we are giving the option to create also. Yeah. But pedestal is there. It is not like the pedestal was not there. That is the reason I'm repeatedly telling you, just try to explore this one, and next week or so it should be released. 2024. This is 2024. Okay. If you need more kind of demonstration on this, please let me know. We have our product manager also. He can also link with your team some specific things of our requirement. Capabilities on Stat Foundation Advanced 2024. One of the good part that we are doing is this one. Say, for example, you have a foundation where water tank and building is combined. Now, if you want to import from stat, you can't combine both of them together, two different forces. So right now, we can combine two different stat model itself and put it in a single stat foundation advanced. So that's the beautiful thing that we are doing it. Now, modeling rectangular isolated footing, that one you have mentioned. Isolated footing we can model and design with the flexible and rigid method. Yes, analysis. See, this is the one. And a lot of different UI and interpretation, illustration we have improved. Because it's not released, so I'm not also have the option to explore it in depth. So once it releases, let me see. Okay.
Luar biasa. Keren.
Yeah. From back, I can't listen anything from you.
Mungkin kita harus ya, Mbak, next.
They are following because a lot of things they know it.
Iya Bu ya, mungkin next kita harus buat training yang spesifik ya, buat bangunan tertentu dengan stat gitu ya. Lebih terus lagi kayak Bu ya. Lebih spesifik lagi Bu ya. Dari A sampai Z. Aduh. Ya. Ibu. Kali. What? Kita break. Kita break dulu kali ini.
Pardon me.
Oh, okay.
After break,
Yeah, we have one session more.
with same team.
Mixing.
Okay. No, I didn't know the plan. What else? If the same team, then first half I would have covered only the concrete. Second half, then steel. I thought the same team in the first half. That's the reason.
Yeah,
Okay.
the bricks still have one session game, different teams.
Different team.
Different
Okay.
teams. But if the same,
Yeah, no problem. Yeah. Almost same thing I will be showing, but I need to know, users' requirement. If they are more into steel, then I will discuss more in steel. If they are into concrete, then if it is mixed, then I have to go with bits and pieces from here and. So hope it was bit informative. Yeah, thanks.
okay, but yeah.
If you need any kind of assistance, maybe I can share my
Yes.
card. And maybe if you need any kind of assistance in the sense, not only technical support, but anything you want to improve in our product, any features you want to improve, don't hesitate to write me. Why I'm telling you, if I write on behalf of you to product manager, you will tell the who asked this, please collect his information. It's better that you send the email I forward to you.
Yeah.
So I'm going bisa di
Oh, yang video tadi.
Yang video sekarang ya? Iya nanti. Video ini.
Rapid tadi.
tadi transfer biaya kan.
Oke.
Nanti saya nambah.
Oh iya, oke. Nanti kita yang begini. Oke, mungkin setelah tadi kali ini.
Habis.
Oke. Oke, thank you.
Call me Vishwa. My name is too long, so yeah. Tough time.
Bapak ikut yang kedua. Bukan lagi ya.
Thank you, sir. Thank you.
Ya, thank you.
Oh, okay. Someone of you asked like Ravi to say I have shown him. I remember to send him. So just drop me an email and send the video from Ravi to start.
Oh yes, I will email you from.
Yeah.
Hari aja Pak di replay.
Me or her anyway. I'll just communicate.
Sorry. Thank you so much. Okay, Vishwaji, thank you.
Thank you.
Oke.
See you.
Oke, Pak, sambut lagi, Pak. Mari, Pak.
Ya.
Halo,
Dengan Chandra.
Oh, Pak Chandra.
Pak Chandra, ya. Oke, Pak Chandra. Salam Pak Rizky ya.
Makasih Pak. Mr. Vishwa, thank you so much.
Oke, siap.
Mr. Vishwa.
Pak Rasul masih.
Thank you.
Yang bagian ya. Oke, mantap.
You mau makan dulu, Pak?
Oh iya, Pak. Salam dulu, Pak.
Thank you for attending.
Makasih, Pak.
Thank you very much.
Lanjut sesi dua.
Any question?
Lanjut ya.
Please ask by writing emails. Okay, don't hesitate. Saya lanjut dua.
Lanjutin.
Ibu, lanjut terus. Lanjut ya. Mantap. Lanjut. Oh enggak lanjut. Oke, mari.
Really? You take any picture?
Buat
Picture.
bentar, Bu, Pak, Bapak Ibu. Kita foto dulu ya. Foto.
Kalau
Pak. Kita foto bentar, Pak ya. Foto.
Iya,
Kita foto ya. Kita foto bentar, Pak ya.
that.
Kita foto dulu, Pak ya. Mana? Kita foto di luar, Bu.
di luar ya Pak.
Iya, di luar.
Second batch is
You want more?
yes.
Kita kayak itu tuh bawa. Makannya di bawah. Emang, please. Come on. Kita advance. Ya, ajak habis. We take our lunch. Di bawah. Together. Oh iya,